So good morning, everybody. I welcome you all to International Conference on Safety, Health and Analytics-Driven Governance for Sustainable Development, SHADG 2024. I am Dr. Richa Ahuja, Assistant Professor in COE-SCA, IIT Kharagpur. And on the behalf of the organizing team, I welcome everybody. Now let us welcome all our guests of honor and chief guests for the evening on the dais. May I request Dr. B.K. Verma to join us on stage, please. And please, can you greet them with a flower bouquet? Dr. Verma is the Joint President, Corporate Safety, Adani Group. Dr. Anirudh Gupta, PD, RDSO Lucknow, please, on this. Please, could you join us on the stage? Thank you, sir. Dr. Imtiaz Ali Khan, Director, Directorate of Human Space Flight Program, Gaganyaan, ISRO. Please, could you join us on the stage, sir? Thank you. Professor O.B. Krishna, Advisor COE-SCA. Sir, maybe can we have you on the stage? And Professor Mehti? Okay. So probably they'll join us in a minute. Professor Krishna, can you please join us on the stage? That is it. So may I please welcome our own director, Professor V.K. Tiwari, to join us on the stage. Our chairman and HOD, Professor Mehti. And Professor Krishna, Advisor COE-SCA and Convener for the conference. So I wholeheartedly welcome everybody in the gathering and everybody on the dais. May I request all of you to join for the lamp lighting and accompanied with Saraswati Vandana to begin the function. या कुन्देन्दु तुषार हार धवला या शुभ्रवस्त्रावृता या वीणावरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युतशङ्करा प्रभृतिभिः देवैः सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा शुक्लां ब्रह्मविचारसारपरमा आद्यां जगद्व्यापिनीं वीणापुस्तकधारिणीम् अभयदां जाड्यान्धकारापहां हस्ते स्फाटिकमालिकां विदधतीं पद्मासने संस्थितां वन्दे तां परमेश्वरीं भगवतीं बुद्धिप्रदां शारदां बुद्धिप्रदां शारदाम्। Please be seated, everybody. Thank you. If I may take the opportunity to introduce the conference to you. The conference is organized in collaboration with our industry partners, Tata Steel, Adani Group, SAIL, academic partners, TRIPSI IIT Delhi, Dart Lab IIT Madras, NIDM, European University Cyprus, Luleå University of Technology, Sweden, Mary Kay O'Connor Process Safety Center, Texas A&M, US, and our IIT Kharagpur academic partners, Department of Industrial and Systems Engineering, Subir Chaudhary School of Quality and Reliability, Department of Mining Engineering, Department of Chemical Engineering, and Department of Humanities and Social Sciences. May I now request Dr. V.K. Verma, Joint President Corporate Safety, Adani Group, to address the gathering. Sir, please could you?
Good morning. And thank you, Dr. Richa. Dignitaries on the dais, Professor Tiwari, Director IIT Kharagpur, Professor Mathi, Professor Obi Krishna, Dr. Anirudh Gautam, Mr. Imtiaz, my colleague Rajiv Mangal has not reached. All the invited guests, faculties and members from the different IIT Kharagpur departments, all the scholars, participants, and ladies. It's my great privilege to be part of this international conference on safety, health, and analytics-driven governance for sustainable development. It's a great honor to be part of this from the Adani Group. I really congratulate Professor Mathi, Chairman of the COSEA, Professor Obi Krishna, Professor Tiwari, for organizing the first conference by COSEA after they get established in 2020. I remember the day in October, November, they got the first building of their own department. So it's a really great privilege to be part of this. Adani Group as such is working with COSEA since last, I think, 2 years, when we started a combined effort for developing the skill on the process safety. We are working with the COSEA through our LPSCA program, Logistic and Process Safety Engineering for Adani officers, which is almost 16 weeks program. And the kind of momentum it has given to the group. So professors are aware about, even the current batch is here. I think most of the people are here. So this is the third batch. They are coming out, I think on Saturday, they will be finishing the course. But I think this COSEA is giving a great platform for the industries and the accommodations to come together and to work on the safety, because as you know, safety is still an evolving science. There are a lot of research happening across. There are a lot of, still the problems are there for the solutions we are looking for. I guess this particular conferences will help us in answering some of the unanswered questions. I personally congratulate the entire team for the way this conference has been designed. So they have divided into 6 parts. One is working on safety, security, and analytics. So generally, you know, when we are in the industries, we always find somebody coming from the outside, and they are not able to distinguish between safety and security. So sometimes I'm also getting introduced as a head of security. Sometimes people feel, so they do not understand the difference between what is safety and what is security. And I'm sure this session will help in understanding, clarifying those requirements, and how does the two data from the two different processes. Because when we talk about safety, it is more on the people's safety from the internal processes, the behavior and the technology and all. When we talk about the security, it is basically risk from the encroachers who are coming to your plant, coming from different threats and all kind of things. So I believe this will help us. The another topic which is very important is in terms of reliability, maintenance engineering, because most of the time when you have a bad practice of maintenance, and when the maintenance are overlooked, it converts into the safety risk, and the kind of problem it has created. The recent, you are aware about the LG polymers, you are aware about many industrial disasters which has resulted out of poor maintenance or incapable processes which they fail to manage the process deviations within the technology. The another which is important part of this is, I think, health, epidemiology and all. Then we talk about risk, resilience into the processes, sustainability, human factor analysis. So I think the entire conferences has been designed in such a way that it should resolve the processes, and it will expose the participant about what is happening in the current technology and engineering part to solve those issues. And also they will help you to get exposed to the newer processes, new research happening across. But ultimately, see, those research we are discussing in these conferences, we keep on working on a lot of research papers coming up. But how does it result into saving life of the people? I only believe that the outcome from this conference should help the participant to even at some extent reduce the risk to the frontline guys who are standing in the last row. And who are getting exposed? You know, the people who are sitting here, we do not have that kind of exposure. People are not that kind of exposed to the risk. People die is the guy who is at the front side, who is highly exposed to the kind of risks. Whether it is coming from the technology, it is coming from the unsafe behavior. It is not the behavior, but is a condition which is helping the persons to behave that way. So even a small improvement in for the frontline workers, if this organization, this conferences can help to reduce slight risk to the front level guy, that will the more, that is the basic objective of the entire seminar I am looking for in the personal way. As you know that with the kind of Prime Minister giving the aspirational target of becoming the third largest economy in the world, so it has a lot of infrastructure project coming up. You have seen the kind of airport which is building up, the kind of road getting developed, the kind of storage facilities getting developed. So all roads are there. So how does we as an institutions or we as a professions, we are able to provide that conscious engineers in the field, they are aware about the safety risk. So that becomes one of the important part of it. I am very happy the way IIT Kharagpur took the lead. They formed I think they are the first among the IITs to form a COAC department, separate department, to build that kind of capacity. So institution has a role. How do we prepare students to be part of the, when they join in the industries, are they aligned to the requirement? I sometimes feel when the new engineers come in, when I talk to them, they do not have any idea of the safety. And I remember, one of the guy way back around 15 years back, one of the bright engineer directly coming from the institute, he joined and he didn't have that kind of exposure on safety. The guy who was heading a maintenance department, he sent the guy to one of the critical risk. I mean, there was a work going on at the height, at the floor. Engineer said, why don't you go and have a look into the top of the roof, what is happening across. And the guy was so eager to know what is happening in the industry, how does he has to know that. He went on the top of the floor without securing himself. He put the leg onto the roof top, which was unstable, which has a crack. He put the leg, it gave away, and he fell down to the 36 meter down. The first day he lost his life. What can be the worst day for the entire organization and for the family? You can understand the family the way and he was the only child. So somewhere we feel that we have to inculcate those behaviors so that when they go industries, most of them are now going to IT and all, but those who go to the industry, are we making them enough consciously safety, conscious team or conscious persons, so that they at least take care of their own, life, and they are not exposed to. At least the moment you have that kind of understanding that this exposure of risk can lead to his loss of life or loss of limb, we will be able to, happy to do that kind of thing. So I believe this conference, the entire effort from all of us should lead some improvement into that. As you know, this year the report has come. We have a highest death on the road. Almost last year, 1.61 lakh people died onto the road. I think every hour we have 7 or 8 deaths on the road. How do we really, there are a lot of research coming up. You might have seen the statement from the Ministry of Road and Transport. Mr. Gadkari is working on to the road design and all. But really, it pains when you see the young guys getting killed onto the road. I have seen some of the technology which has come out. I was just reading a newspaper and the video onto smart poles they are creating for warning the people onto high-speeding vehicle onto the blind curve. So I believe some of those technologies should be there so that those unresolved issues can be addressed onto that. So that's what my belief is, that this entire course entire conference when we end tomorrow, the participant will have a lot of knowledge, a lot of benchmarking practices to go back and do something onto the work. All the best. Thank you very much.
Thank you, Dr. Verma, for highlighting the need part of it. I now request our chairman, Professor J. Mehti, to tell us about the center, the conference, and how we are going to go about it. Sir.
Respected dignitaries on the dais, on the dais, Professor V.K. Tiwari, our director and chief guest of this function, Mr. V.K. Verma, Adani, Joint President, Corporate Safety, Dr. Anirudh Gautam, Executive Director, RDSO, Lucknow, Dr. Imtiaz Ali Khan, Director, Directorate of Human Space Flight Program, Gaganyaan, ISRO, and my dear guests and participants, dignitaries, students, and organizers of the dais. So, as chairman of this center, Safety Center, Center of Excellence in Safety Engineering and Analytics, I'm really privileged to be here and to be part of this international conference on safety, health, and analytics-driven governance for sustainable development. So this is probably the era of safety, health, and sustainability. If you talk about the earlier, the last century on quality, and this century obviously for this purpose. So I am thankful to Dr. Verma for speaking about the different tracks for this conference. Obviously, we have 6 different tracks, and in all of the tracks there are some papers, although the concentration is more on safety, security, and analytics, reliability and maintenance, and as well as sustainability, health side in this order. And we got more than 160 submissions, and ultimately, as per the review process, we finally going for around 130 presentations. And in fact, in the entire conference, the schedule already, which what you have, you can see that there are different sessions. Like immediately after, with this inauguration session, there will be a keynote by Dr. Imtiaz Ali Khan, the Director of Human Space Flight Program, ISRO. And then after that, there will be plenary offline keynotes, and that will be held in this room as well as in the next room, that Moitri. So here, so depending on the your choice, you may go to Moitri, you may be here. And after that, our lunch, after lunch, then I think all the schedule is there. I don't want to extend this, just mentioning all those things. It is already there in the kit, so you can see this. So Dr. Verma already said about that center, when it established. I can tell you that this center has been established by our beloved director, Dr. V.K. Tiwari, Professor V.K. Tiwari. It is, I think, I request the participant to give a big clap to Professor Tiwari. Because of him, this very important center came up, which will ultimately I can say provide support to the industries, and from the industry academia interaction point of view, perhaps this center has probably the bigger role. And I am sure with the help of our participant industries, we will be definitely able to do it. As you have seen that Adani, Tata Steel, SAIL, Vedanta, IPCO, and Mahindra, and many other organizations who are helping us in the development process. Although we could not approach to many of the industries with which we are still working, like Coal India, like Haldia Petrochemicals, Also the labs, government labs like DRDO, ISRO, so all are coming together to help us, and we are getting appreciation and support from all of them. So that sense, once again, I show my deep respect to Professor V.K. Tiwari for establishing this center in the premier institute, IIT Kharagpur. And what we are doing in the center? In the center, although it is very new, I can say it is just like has taken its birth in 2020 July, but in the 2.5 or around 3 years, we could have reached to many industries. We could have developed so many programs, particularly what Dr. Barma says, the Adani, that capability building on safety engineering analytics going on, process safety engineering going on. So we have PhD program for the regular students as well as working professionals. We are again with the kind support, and I can say the enthusiasm of Dr. Professor V.K. Tiwari, we are going to offer M.Tech program in safety engineering analytics from this autumn, and you will be very happy to see that there are process safety engineering management, occupational safety engineering management, occupational health, human factors, analytics, and leadership and management. All those subjects we have basically put together in such a manner that the people who will be doing M.Tech in safety engineering analytics, they will not be just like the safety manager or the safety officers in the plant. They can go along the ladder up in the organization, and I think probably the MD or the top the head of the institution would be the best person who will basically talk about safety. So in that sense, it's a huge scope for industry professional also. You can join because we have regular as well as sponsored candidates opportunities. By regular, we have 15 candidates, and for sponsor, industry sponsored, 10 person can join in this program. So there are other issues, but I don't want to extend my speech because of the time constraint, and we have already shared with you all those news, whatever we are doing in the kit, so please go through. And already Dr. Richa mentioned that who are the partner for this conference, not only the industries, not only the academia within India, not only the department, some of the department within IIT Kharagpur, we have our academic collaborations in US, UK, and Europe, you can think of. So it's another great opportunity for all of you to interact with some of them. And apart from this, again, I definitely I'll definitely appreciate all the helps and support from all the organization, and I heartily welcome all of you to this conference, and please be in the conference venues, in the particularly for the except the paper presentations, only Gargi and Maitri is involved for other things, and on evening time our online plenary keynotes are there, as well as tomorrow morning plenary keynotes there. Tomorrow morning there is one keynote by Dr. Anirudh Gautam. So it's a complete package, I can say, because Dr. Gautam will be talking from the railway safety point of view. Okay, so with this, I once again welcome you, and thank you so much for joining us.
Thank you so much, Professor Mehti. May I now request Professor Anirudh Gautam to join us on the dais.
Professor Tiwari, Director IIT Kharagpur, members, honorable members on the dais, honorable members in the audience. First of all, I have to thank IIT Kharagpur and the center and Professor Maiti for inviting me to this conference. represent the Indian Railways safety point of view and what we're trying to do in safety, reliability, etc. As you know that Indian Railways have had some very serious safety related issues, especially the Balasore accident. And then of course there have been some minor accidents as well. On the railways there is a full-fledged railway safety organization, and which is headed by Director General Safety in the Railway Board, and then we have safety organizations in each zonal railways, which is headed by a Chief Safety Officer, and then we have got to the grassroots level safety inspectors and so on and so forth. So on the railways, safety is a very, very important and a very crucial issue. Trains are running 24/7 and carrying passengers, goods. Many of you must be using the railway services. So it is but in the fitness of things to be very much concerned about the safety. I'm very glad that under the leadership of Professor Tiwari and Professor Mathi, IIT Kharagpur, I think, is the first institute to start a Center of Excellence on safety. And I was just mentioning it to my Director General Safety in the Railway Board, Shri B.M. Agrawal, that we can consider or discuss about a long-term relationship between the center, IIT Kharagpur, and the Ministry of Railways for the safety. I'm very thankful to IIT Kharagpur, Professor Tiwari, Professor Mathi to have thought of this as a structured safety propagation, and I think it will bring great value to the country and to industries like Indian Railways, specifically since I come from that side. So once again, a big thanks, and I hope we make use of this center and the expertise here. I've been interacting with the Center for Reliability for since a very long time. So it's an excellent place. IIT Kharagpur is the, I think, unique institute to have the RAM safety under one roof. I don't think anywhere else in the world you have such a setup. I wish them all the best and hope for the for your success in the future. Thank you so much.
Thank you so much, sir. I would now request Dr. Imtiaz Ali Khan, Director, Directorate of Human Space Flight Program, Gaganyaan, ISRO, to address the gathering, please.
Thank you, Dr. Richa. Good morning, everyone. Dignitaries on the dais, Director Professor V.K. Tiwari, Director IIT Kharagpur, Professor Mathi, Professor O.B. Krishna, Mr. Anirudh Gautam, and Mr. B.K. Verma, and also from IFCO, Mr. Mohapatra, and other dignitaries, faculty members, and students. So I'm glad to be here for this conference. First of all, because coming back to IIT Kharagpur, which is such an esteemed organization, one of the oldest, one of the largest IITs, one with I think the largest number of departments, students and faculty, but more because once again you can see after coming here that birds are chirping and bees are buzzing, which is such a rare sight to see in large metropolitan cities. Now coming back to the theme of the conference, I think I can relate to this theme very well because safety, health and analytical driven governance for sustainable development, the last bit of it in my earlier assignment, I had the good fortune of representing the country at United Nations Committee for Peaceful Uses of Outer Space. And this was during the period 2014 to 17 when the goals for sustainable development were being set at United Nations. And I think safety is a core when we talk about sustainable development. I started my career at ISRO at Vikram Sarabhai Space Center in a rocket propellant plant. And safety is, I think, sort of imbibed into the very culture of ISRO there, because it starts from the design phase. right from conceptualizing the buildings, for an explosive plant, as many of you may be aware, you go into these layouts wherein you have well-defined propellant internal quantity distances, so the buildings have to be far apart as per that. Then there have to be Merlons, there have to be blast walls, flame-proof fittings, deluge systems, sprinkler systems. So the point here is that you go for all this additional investment not because it's going to be required every day, but it is because there could be one day when it could be catastrophic. So safety, from a safety viewpoint, it's very important that you plan for that one day. In our system, we have many forums of review. We have plant level safety, then we have entity level, center level, and the final launch clearance is given by the launch authorization board, which is nothing but a safety review. Of course, we have a good quality system of checks, good reliability system of checks, good design system, but the final clearance is given by the launch authorization board. So that is the importance, the paramount importance given to safety in our system. I'm glad that this conference is arranged. I hope the key to safety is, of course, information, knowledge, training again and again, so that it becomes part of yourself. It becomes like a muscle memory in many cases, and that's very important. So I wish you all the best, all the presenters here, and I wish the conference very best. Thank you.
Thank you so much, sir. It is really inspiring to hear from all of you. Now I request our director, Professor V.K. Tiwari, to join us and guide us through the conference.
Good morning to all of you. Sorry, I have a bad throat for the last 2 days, so please excuse me for that. I welcome each one of you here, and especially the people on the dais. Of course, Mr. Rajiv Mangal, Vice President, Safety, Health and Sustainability, Tata Steel, he is yet to join us, but I think in absentia I would like to welcome him, because after this session I will be not here. Then we have our very good friend V.K. Verma ji, Vice President, Joint President, Corporate Safety, Adani Group. Verma ji, you had been a great source of inspiration to us here. Not only this, I think I will tell you the history. Then we have Dr. Anirudh Gautam, RDSO, Lucknow. I think we welcome you, sir, for this event, and I think I'll tell you that we have to go a long way, and we had several interactions with railways as well earlier. Then we have Dr. Imtiaz Ali Khan, Directorate of Human Space Flight Program, Gaganyaan, ISRO. I think we are all interested as to what Gaganyaan was and how things have taken place, and over the last 5 years or so, when we could not succeed first time and the next time we succeeded, I am sure that people will be all very much excited to listen to you when you give your lecture. Well, now, so welcome all of you friends. I think first of all I would like to congratulate my faculty friends, Professor Maiti and Professor O.B. Krishna, and other student friends and other faculty colleagues who have helped in organizing this particular international conference. I can see some of my faculty colleagues and deans, etc., from various departments, and all the members who have come as participants for this particular international conference. Well, let me tell you that it was said that I have started. In fact, it's not so that I have started as such, but let me tell you that in 1979, when I started my MTech, that time I was introduced to the course of ergonomics and safety. In fact, in 1979 to 81, when I did my MTech, at that time my boss, my Guruji, was expert in ergonomics. And right from that time, when we were also sitting on the tractor, my area is agriculture engineering, and I am a farm power machinery engineer. So when we used to sit on the tractor, a lot of difficulties used to come, and I have a lot of data about the about the difficulties and the health issues of the tractor drivers. Therefore, we started working on that, and not only that, the various types of devices which are used in agricultural operations, I think many of you might not have seen, but I think those operations give arduous posture to the body. And when you are in a different posture, you would not be in a position to employ the maximum effort that you have when you want to apply. And therefore, right from that time, I got addicted to understanding what ergonomics is, what human-machine system is, and what is human-machine system performance is, and then what are the other aspects of safety and performance. Because until unless the person is safe in an ecosystem or an environment, he will not be able to perform well. I think if you talk of reliability, well, I think the person has come, right? Rajiv Mangalji, I have welcome here. I think very nice of you that, yes. So it's great that we can see our turtle man here. Fine. So initially it is very difficult, and until unless you do not understand the difficulty of what a man-machine system and environment does to a system, you will not be able to appreciate. So right in my MTech I did something, and PhD I took up another topic in which in fact I got a national award as well for the work which I did. And right from that time I have been working for my with my MTech students, with my PhD students, and the Department of Industrial Engineering in 1987-88 I think I had gone, because when I got the award, one of our professors came back and he wanted to learn as to what is the type of work this fellow has done. So he was given the award. And when he saw that the work was related to ergonomics and safety, he said that you should be taking some course in the Department of Industrial Engineering. And therefore, I took a course on work study and work methods, etc., related to ergonomics as well in as back as 87-88. And with other professors, Professor, I think Professor Sudan Sahu, Professor another Sahu who is, he is no more, Professor, Professor K.C. Sahu, yeah, we lost him, I think about 6-8 months back, March last year. So I learned, and right from the time I was interested to think of safety. You know that we do have this particular IIT, as Imtiaz was just telling, that this particular IIT is the first of the IIT in the whole system of IIT, which started in 1951 on the advice of a committee which was in fact organized on a committee which was constituted in as early as 1948. And on that, the first IIT, the first National Institute of Higher Learning came up at this particular venue, and it came out in the Hijli detention camp. You must have heard that there are certain detention camps or jail in which this institute is started. It's a fact. You should see. I think maybe Professor Obi Krishna and Professor Maiti should take you to the locations, because we have still preserved those cells. Those prison cells we have preserved. The building in which the other Sangramis were kept is the building in which we started, and we call it a Sahid Bhavan now. And in fact, since I was a BTech student here and a resident of this campus, I had also seen the gallows and also a isolation room which is still there. You can see that before the people were hanged, I think where they were used to be kept. So you should go and have a look at that. But I can tell you that this is a beautiful campus, and this campus is having AQI of, you cannot imagine, even between 20 to 30 only. Other cities you will find that the buzz of the city is very much there, but I think you will starve for AQ of something below 100 or so. But we have this AQ. We have a wonderful atmosphere nowadays when you have come at this place. Well, when we were in 2002, 2003, I think we were introduced to Tata Steel. And I was introduced to a man in Tata Steel, and that man is seated here, O.B. Krishna. And in fact, the Tata Steel has ergonomic safety and health department, and he was in fact the safety officer at corporate safety, I think bigger positions of all India and all that. And then we were given certain aspects of working on design of a cabin, and that cabin was about 60 feet in our rolled cold rolling mill. I think yeah. And in fact, I had gone. There is a monkey ladder in the last 10 feet that you have to go, and I had gone. I don't know how many of you know. I had gone there. Maybe yes. So I had gone there, and I felt as to what is the problem of the people who are actually working with that setup while they are trying to put the nitrogen purging inside the system, while they were lifting the whole dome and then they were keeping it over there. And it was the pressure over here, looking back and then looking at the various postures. So right from that time, I think we wanted to work. There was a challenge, myself and I think myself, Professor P.K. Ray, I don't know, P.K. Ray is not here, Professor P.K. Ray and Professor Dan Sahu. We had gone, and they wanted that please give us a proposal. We gave a proposal of 40 lakhs. And that proposal, in fact, Mr. Sen Gupta, he simply said that, well, because I was leading the group, because I had the experience of working in design of cabins of tractors. So he says that, well, you have designed the cabin of tractor, but this is different and all that, so we'll not give you that much. And he said about 10 lakh rupees or so. And I remember that I said, we'll not take any paisa. And we did not take, but we involved 2 students, and then we got the thing done. And still I hope the cabin stays, right, O.B. Krishna? Yes.
That cabin has now become universal across India for all the cold rolling mills, for all the batch annealing furnaces. That's become a standard.
Yeah, so that's, they call it IIT dream cabin. And I think that cabin was made free of cost to Tata Steel. But after that, I think I'm grateful to Tata Steel that we conducted several courses on safety engineering, and they helped us. They gave more than 1 crore of rupees in various short courses, and I think we learnt a lot during this process. Right from that time, I think we thought that there should be a course, because the requirement of the technology and the systems that are taking place over the period of time from last 15-20 years or so, you cannot think of even a single disaster that happens in the factory, any factory for that matter. And therefore, because the compensation you have to give, and apart from the compensation, even you have to think of what is the life of a human being. It's very, very, very important. And therefore, while we introduce the technology for easing the work of the human being, or in fact increasing the efficiency of the system in any production system, I think you will have to think of how the technology which has been brought into acts and reacts with the human being and the total ecosystem which has been developed and the environment which has been developed. And therefore, when you are talking of the interaction between the human, machine and system, I think you will require what is the reliability of the system, what is the quality of the work that is being done, what is the quality of the work that the machine does, what is the quality of the interaction between the machine and the human being and the environment, and how does it affect the overall production system. You need to do all these things, and for that I think lot of data is required, lot of analysis of the data is required. So in this context, I think the conference which talks of conference which is talking of what is that safety engineering and analytics and analytics. They say that safety, health, analytics and driven governance. I think when you talk of governance, we are all talking of how best we should be producing, how best we should be giving a system to the whole production group or to the management. Because ultimately when you are talking of governance in a production system, you are talking of how best you put the people who are there, the machines which are there. You can also see that it should not be misused. The machines should not be misused by the person. So therefore, there is a requirement for training of those people. Now gone are those days when we were thinking of legacy solutions for any problem. Earlier we were not bothered about what is the solution of a particular problem. We know that, okay, if something happens, this is what is the solution in some way or the other. But I think as the technology has changed and the bringing of technology into the system requires that you do train, you further the capacity of the people. You must give training to the people who are already in your system, who are dealing with, because they are now 10 years beyond their schooling or the university that they have left, and once they have come over here, they are going to interact with a higher level of technology. So there has to be an interaction, and there has to be training and capacity building of those people when they are brought, and that is how there was a requirement that we should have a place where there should be talk of reliability, quality, safety, and then what is the analytics of that? How do we analyze the data? How do you take this data and talk about what is best required, and how far our people will be aware of the new systems, because then only they will be able to give you maximum. In this context, we were thinking of having a center, and when O.V. Krishna joined here, in fact, I must tell you that O.V. Krishna was only 58 or 59-year-old, but he was younger than a 24-year-old when he was doing PhD. So give him a big hand. And the way he was making friends with the 24, 25-year young MTech students and PhD students, I think that was marvelous. And I said that we must learn from him what is called camaraderie of working with young friends. And possibly he has picked up all in his workplace at Tata Steel, and those are the things he gave something in the industrial systems engineering department. And because in a department like this, I think we have to have more of interaction, more of dialogue than talking of analytics as such. So when he joined, we thought that why not we have the outcome of interest and interaction with Tata Steel. We should have a course on this. In fact, I had also conducted an international conference in 2016 and 2014 as well, where on safety we had ergonomics and safety and health. We have kept a particular session, and that session was sponsored by Tata Steel in 2004 December. And right from that time, we got an idea that something has to be done. And therefore, when I got an opportunity to be the director of this institute and Tata Steel was still connected, we thought why not do something in this line, because as such you might have seen that in this institute we have several centers of excellence. Because when we joined, when I joined the institute in 2010, in fact 2019, 31st of December, so the 1st of January 2020 we felt that there should be a mission of this institute, there should be a vision of this institute, and then we decided that let us work for the top 10 in the world. What is our ranking at present? So our ranking was 314. So we have taken a very, very stiff target, as somebody was saying that the government has taken a stiff target of becoming the third highest economy in the world. I think we are also taking something like that, and we thought that we should be the top 10 in the world in the QS ranking. And it was not possible because we have about 20 departments now. Department of Education has also been opened on the advice of the Government of India. And in these departments it's not possible because the department's requirement and the teaching program varies across. And therefore we wanted that we should have certain niche areas in which we should be working. And therefore currently we are working in some of the niche areas which you might have seen, that G20 declaration. The Government of India has already the presidency for last 1 year, in which we had decided that across the globe, when we are thinking of Vasudhaiva Kutumbakam, when we are thinking of becoming Viksit Bharat or Develop India by 2047 and neutral, carbon neutral, I think we need to work on certain areas. We are working on, we are working on the hydrogen, we are working on energy, we are working on safety, we are working on health, we are working on artificial intelligence and semiconductors, then we are working on the environment, we are working on rare earth metals. I think gamut of areas that we have decided over the period of time and also the sustainability. Ultimately, when you talk of all these developments, you are thinking of sustainable development, and that's why this particular conference also talks of that development of governance of and sustainability in development. Whenever you are talking of these, it seems you need to have an ecosystem where there is enough energy, where there is enough food, here there is enough water. I think these are the requirement for sustainability of any organization or any system as such. And when you think of the whole earth, as we are talking of Vasudhaiva Kutumbakam, I think we are talking of the whole ecosystem that we have, and therefore we need to work collectively on all these factors. And that's why we have different centers of excellence. We are working on affordable healthcare, we are working on advanced infrastructure, we are working on advanced artificial intelligence and machine learning. Then we have advanced manufacturing 4.0, and then we have on advanced transportation. We have several areas in which we are working, and therefore we wanted in those lines, because we are also having a department, a center of excellence on quality and reliability. So matching with quality and reliability, I think the center of excellence on industrial engineering or engineering analytics was started. And the need today, as I think V.K. Verma and maybe Professor Maiti has said, that we are going to start an M.Tech course. And I think here the need of, while we are talking of the academia, I think there is a need for industries. I am very happy that Adani, Tata Steel initially, and of course Tata Steel has been doing a lot, and I could know that such cabins have been taken in all the other locations, very nice of them. I think this is a good requirement that industries and academia work together, and a conference like this is the platform where all of you who have come from their various locations, there are six tracks which have been decided for parallel sessions for discussing on various aspects of safety, various aspects of health, various aspects of ergonomics, human factors, various aspects of sustainability, energy, and things like that. And I am sure that all the discussions which will take place for the last 2 days, today and tomorrow, will definitely benefit all the people who are over here, and they will just definitely have a lot of takeaway from here. And the courses that we are thinking, I will like to invite all my, I think I can see that many of the industry has come forward to sponsor these projects. I will tell you that let us work together, friends. I think this is high time that we should be working together, academia and industries. You must be knowing that National Science Foundation of US and the National Research Foundation of Government of India, I think we are working together on various topics for the whole growth of the whole globe. And in that context, here I would say that industries must come forward. We also want to come forward and have such courses. Now in this I would like railways. We did, I think I also attended a course, and I took some lectures also in railways as well. We had conducted few in the Department of Industrial Engineering. And there are railway safeties. One, of course, Anirudh has already said about some of the things which are happening. But I think there is a requirement of various other aspects to work on safety in the railways, in the road safety. Many of our friends in the civil engineering are working on road safety, and he was talking of Nitin Gadkari, who is very much concerned. And that's why the quality of the roads that you would see. Infrastructure development. Over the years, the infrastructure development has changed in the last 10 years. I think it has changed, and the amount of fast track that has taken for the development of the infrastructure across the country, while you can see the number of airports he was also mentioning, is just amazing. And I think the capability this country has is tremendous. What is lacking is possibly our soch. There has to be a change in our soch, our thinking power. We must come together. The industries are the powerhouse where they have the where they want the expertise, where they want to produce more and bring down the cost of any unit product which they have. And that is only possible when we come together. So in the conference like this, when the companies have come or the industries are coming together with the academia and the students, I am sure many of the students will be also attending these various track sessions. It will go a long way. I am confident that such thing will happen again and again. And the name which is given SHADG 2024 will have 2025, 2026, and so on and so forth, so that this legacy continues and ultimately we are in a position to do something better in future. With this, I welcome each one of you and open the conference here. Thank you very much.
Thank you so much, Professor Tiwari. I may now request our guest of honor, Mr. Mangal, to join us on the dais.
Thank you. First of all, I apologize for the delay. Dignitaries on the dais, visiting delegates, students, faculty of IIT Kharagpur, members of the organizing committee, ladies and gentlemen. Thank you for giving me an opportunity for sharing my views. It's always a pleasure to come to an academia institution, because you got to talk to students. I hope there are few students here, for they are the future leaders and you are the ones who are going to lead this entire system going ahead. I'll keep it brief and I'll keep it focused more on safety. Possibly on sustainability I'll talk later when I get a chance. Safety remains a matter of big concern in our country. It does not form part of any curriculum either in school or college, okay? And due to various reasons, we take pride in jugaad, you know, what we do day in and day out. But if one were to test the jugads which we do at home or shops or small establishments and put it to a test of safety, I don't know how many of them will pass, okay? Condition of roads and the road traffic is what we are all aware of. Now, it is with this mindset that youngsters enter the business or the industrial environment, and they are supposed to behave in a certain manner. So they get trained on standard operating practices, what are supposed do's and don'ts and things like that. What I've seen in most of the organizations, these trainings are more from a compliance point of view. You comply to an ISO standard or you comply to labor law, but the depth of that training or what should be done on the shop floor or in the factory is missing in many, many organizations. And hence, the actual commitment of quality resource, whether on safety, whether on training, whether on technology, is not adequate, resulting into accidents. There is plenty of numbers available on accidents. The question is accident a statistics? Is safety a statistics? For many, possibly yes. But if you think it, as Professor Tiwari also said, if you think it from the perspective of the family who got injured, or the family of the person who lost somebody because of an accident, for them the whole world changes. Each one of us may be insignificant in this world, but for our family, we are the whole world. Faster the organizations realize this, different will be the approach to safety, and that is what is needed. When I meet and travel, I see this realization percolating at least in the organized sectors. In unorganized sector, in small industries, we are still far, far away. I got a chance to sit in CII Eastern Region safety meetings and safety visits. We are far away from what we think safety should be on the ground level. Responsible organizations value safety and they believe that every injury can be prevented. That's a very important perspective. Unless we believe that every injury can be prevented, our approach to the subject is going to be very, very different. It is also well proven, research is there, good safety is good business results. So it's not only about charity, it's not only about human aspect. Because if an accident happens, the unit goes down. Indian laws are also becoming stricter, but if you have an accident outside, okay, first thing they do is shut down the factory for 15 days. They say we'll talk on 16th day. Okay, so if you put the cost of a downtime because of an accident, and this is only going to become stricter and stricter going ahead. So safety, as what we believe, at least in Tata Steel and Tata ecosystem, it's a leadership issue. It's the leadership team that sets the culture in the organization. And that culture decides, is there enough transparency and freedom to report an issue? Are there enough gadgets available? Are there enough technologies available to do analytics, to put CCTVs, to analyze what is getting captured over there? Is the voice of safety officers heard?
or they are seen as a problem makers. Because safety guy is supposed to come and report a problem. They are the conscious keepers. Do you hear them, or you say, Kalana, I don't want to see your face? Okay. Now that sets the culture in an organization. Okay. So when I see some of these things, even in our site and plant visits, so one of my questions to my team is, if this is the unsafe act or condition, would you allow your children to work in such a situation? Obviously, everybody says no. Then why do we allow our other people to work here? Safety starts with me. So if we follow a paradigm, I am responsible for my safety, and I am responsible for safety around me. That is where the safety culture gets incorporated and deployed. Unless we reach that stage, we will continue to have issues, and we will continue to create fatalities and serious injuries in the society. So safety is about demonstration of care. Do you care for somebody as a human being? Let me touch upon quickly another aspect. While safety is physical, you can see it, these days what has also picked up importance is emotional well-being, the amount of stress that is there in the system. Data shows more than 85% people have some sort of a stress in the system which is not measured. It's not easy to see. And that adds to the productivity challenges at site. So, and this is cutting across, this is only blue collar, it's also in the white collar jobs. So just to keep concluding, safety and employee well-being is an absolute and very paramount factor for any society and any industry. Better and earlier the organization realize it, faster they move on this journey, and we need tools to do this, and that's where conference and symposiums like this become handy. So I hope the participants, including my colleagues who are there from Tata Steel in the next 2 days, they'll pick up ideas what can be extended to them, to the areas where they work, so that together as an organization, as a society, we improve. If we practice it, it gets ingrained into us. And then it becomes, for each one of us, it becomes 24/7 safety, and that is what makes each one of us a safer person, whether at office, whether at home. Okay. So once again, thank you for giving this opportunity. I apologize for joining late, and I wish the symposium all the best. Thank you.
Thank you so much, sir. Thank you for joining us. And now I request Professor J. Mehti to facilitate the guests, with the mementos. Dr. Verma. Dr. Mangal. Professor Tiwari, everybody. Big round of applause. Mr. Ali. Mr. Imtiaz Ali. Mr. Anirudh Gautam. Thank you, sir. Professor Tiwari. Big round of applause for Professor Tiwari. Thank you, sir. I kindly request Professor Krishna to give the vote of thanks for the inauguration ceremony.
3 minutes, not much. This is basically an academic conference. SHADG 2024 is the academic conference. Let me first thank my academic partners, DART, Lulia University, Merivo Corner, European universities, CIDAR. They are all foreign universities. Also, we have partners from within IIT Kharagpur, the departments like chemical engineering, mining engineering, quality and reliability, and HSS. Energy, okay. And more importantly also, we have 26 plenary speakers, keynote speakers, half from India, half from abroad. And we have more than 100 presentations. We have student workshops. We have student competitions. All these things comprise energy to this whole conference. I thank all of them. Without money, nothing will move in these conferences. So my industry partners like Tata Steel, Adani, they are the platinum sponsors. We have SAIL, and NIDM, madam is there. They are also our sponsors. And we have some other companies, we have IFCO, others who have Vedanta, who have sent a lot of delegates. I thank all of them. We have 4 eminent guest of honors. We are really fortunate. Like Mr. B.K. Verma from Adani Group, Rajiv Mangal from Tata Steel, and we have ISRO from Imtiaz Ali, and from DRDO, PED DRDO, Anirudh. I am thankful to all of you. You have given very good guidelines to us. You are all great support to us. So persons, industries like you, if you are with us, the academic conferences will flourish greatly. I have to thank, should I say chief guest or chief of host? Sir, you are all in all. This IIT is being guided by you. This COE SCA, which is holding this conference, is the baby of you. You created it. You are a specialist in safety. That's why you understood the requirement of this Center of Excellence in Safety Engineering and Analytics to help the industries across the world and also academics. You, as a safety specialist, you helped a lot of industries, especially Tata Steel. You helped for 12 years. We remember your contributions. And your guidance is always very valuable to us. Thank you very much. There is organizing teams behind this, because we have to conduct plenary sessions, 7 tracks, things are happening, 7 venues happening. We have huge team of organizing committee led by Professor Maiti. We have committees, secretaries, faculties, students, office staff. Preetham is standing there, working day in and day out to make this whole conference very, very successful. And we have supporting functions like CET team, audiovisual team. We have IIT's central facilities. They are helped us to do this. Also, most importantly, the delegates. Many delegates who have come, who are still coming, keep coming. I thank all the delegates, especially we have many number of delegates from Tata Steel, Adani Group, and other organizations. Thank you very much. Finally, I should thank Richa also for doing this excellent job. Thank you all. Thank you, Richa.
Thank you, everybody. Now, as we move on to the keynote speech by Mr. Imtiaz Ali, I request everyone to join us in the audience. After 5 minutes? After 5 minutes, we'll start with the keynote speech. Welcome Mr. Imtiaz Ali. Mr. Ali is an IAC Bangalore alumni. He joined Vikram Sarabhai Space Center ISRO, Trivandrum in August 1999, contributed to the development of many new propellant formulations, grain designs, and processing techniques. His prominent works include a patent for a novel casting technique for thin webbed grains. He was awarded ISRO Young Scientist Award for the year 2010 and received HEM-SI MR Kurup, a Gold Medal Award in 2021. Currently, he is serving as the Director of the Directorate of Human Space Flight Program at ISRO headquarters. He is responsible for driving pragmatic commitments, interagency collaboration and related approvals. Today he will be talking about his experience on safety, reliability and data analytics from Indian Human Spaceflight Program, Gaganyaan. Let's hear from Mr. Imtiaz Ali with a big round of applause.
Thank you, Dr. Richa. Am I audible? Do I need to control working? Thank you. So, welcome back.
You can use this mic. It's okay, just let it be.
Right. Okay, so today primarily I'll be focusing on Human Space Flight Program, which is a new domain for the Indian Space Research Organization. I'm not getting into general the way reliability, quality and safety is dealt in ISRO, because this is a setup that has evolved over the years, and we've got a good system working, like especially in terms of quality and reliability. I think it goes without saying that if you are executing something for aerospace, safety and reliability has to be an integral part of it. So the way we practice it is like, of course, there are documents, there are standards that you must follow, but then more importantly, it starts from the design phase, and during the production, you also have the online quality assurance team that is there always. So there are these two sets of documents that get ready. You have the production document and you have the QAP, the quality assurance document, and these both go along with the product. Like in our case, when we are making the solid rocket motor, we used to call it as the travel log. So the travel log travels with the case wherever it goes, from the hardware, then the installation facility, the propellant processing, assembly and things like that. And finally, before the flight, this is what sums up the summary of the whole rocket, how it has been processed. And actually in the review forums, like the design review teams and the flight readiness review and mission readiness review, it is the quality team that gets to present about the product. So if there are any deviations, again there are redressal forums for that. Like you have the local salvage committee, the non-conformance review board, and finally it goes to the DRT once again for clearance. So this is a system that is now well established. I'm not going to discuss about that, but I'm going to discuss about human spaceflight program, which has got wider implication for the whole society. And so I'll just start with a few slides in a general way, and then I'll go over to human spaceflight program. So we all at ISRO love to start with Vikram Sarabhai. because he's the person who's a founding father for ISRO. And very importantly, his vision said that for us, space activities in a developing nation is not about competing with the world in terms of supremacy, but it is more about applications of these advanced technologies to the real problems of man and society. And this is what ISRO has tried to do over the years, as you can see from the subsequent slides. So essentially, the Indian space program, the cornerstones, there can be categorized broadly into 4. One is the technology development, wherein we've developed the launch vehicles required, the satellites required, and then the applications in terms of Earth observation, communication, navigation, and these have been mostly focused around the society. There have been things like telemedicine, teleeducation, disaster management. But we've also done some missions for space science and exploration. Director IIT Kharagpur was mentioning about Chandrayaan missions. There have been mission to Mars. There has been AstroSat satellite and things like that. And we've over the years, we've established some very solid ground infrastructure across the centers, which is what is essential to a space program. But apart from the facilities and the work across ISRO centers, the work of academia has been very important. We have the sponsored research program called as RESPOND, wherein the academia contributes. In terms of space science, various national institutions come into play. We have collaborative development, we have skill development, and many student satellites have been launched. The industries have been a very important contributor to the program. More than 500 PSUs and MSMEs contribute in terms of subsystems, parts, technical services. There has been technology transfers, and now many of these industries are competent at global level. Some time back I was in Delhi and I was a member of this intergovernmental export control body, and I was happy to see that many of these industries are now exporting to countries which were earlier thought of leaders in space technology. So that was very heartening. Over the years, we are also trying to reform the system. We are trying to open it up more for the industries. Now, in the 2020 space reforms, there are provisions in space has been created as the Indian National Space Authorization Center. So it can authorize space activities by industries. And these are not just, something that is deliverable to ISRO program, but end to end, they can have independent activities. We are also operating in this GOCO model, just government owned and company operated model for low volume and high precision components. Then in terms of indigenization and commercialization, a lot of progress has been made in alloys, in many chemicals, adhesives, propellant systems, and flight subsystems and engines, ground systems, and services and data products. Many good industries have come up. Map My India is a very good example, but there are many others who use now geospatial technologies. Many spin-offs have come from space. So this sums up in a brief way. If you just look at the journey, how we've progressed, I think we started in early 60s. We were still under Department of Atomic Energy at that time, and later on Department of Space was created in the year 1972. And if you see the journey in terms of rocket, we started with small sounding rockets, which could go up to 70 kilometers altitude with something like 1 kilogram payload. But today, we can go all the way up to Mars and to the geostationary orbit, or which is 36,000 kilometers, which is kind of benchmark to compare across the sectors. We can put something like 4.2 tons in orbit. In terms of resolutions, from 1 kilometer in Bhaskara, we are now at 28 centimeter resolution for Earth observation. We can build communication satellites. We have an indigenous regional navigation satellites of our own, and various applications that come out of this. And as I said, many exploration missions as well. Now, looking at this progress, the interest has always been there that why not also try to see what is there for us as far as human space exploration is concerned. And if you see globally, there is a renewed interest around the globe in exploration. So, and this time it is not just the industries, it's not just the national space agencies, but also the industries who want to go to low Earth orbit, they want to go to cislunar orbit, they want to land on Moon, they want to go to Mars, they want to go to asteroids, and there are various purposes for this. it seems that there are models which work on commercialization aspects too. People are talking about space tourism, space resources exploration. People are talking about maybe solar energy, maybe in situ resource utilization from these planetary bodies. So it makes a good convincing case for any established space program as ours to look at human space exploration as well. So we were working on the concepts, the requirements required for a human space flight in the country, and there was a national level team which worked on the kind of the technologies that are required, the kind of money that would be required to have human space exploration. And it takes some time in a developing country like ours to have ambitious projects like that. But we were working on certain technologies. In 2007, we had this space capsule recovery experiment. So we could demonstrate the thermal protection systems required to withstand the re-entry temperatures involved. We were upgrading the launch vehicles. So in 2017, we could have the first flight of GSLV Mark III rocket, which had the capacity of carrying 10 tons to low Earth orbit. We were also working on technologies for the crew escape system. So we had this crew module atmospheric re-entry experiment called as the CARE mission. Then we had a pad abort test. And by 2018-19, we were ready to go to the government back again and sort of get approval for the human spaceflight program. So the main points for this program is this is a national endeavor. Unlike the previous activities where essentially it was Department of Space supported by industries and academia, this is a national endeavor. So what it means is that the stakeholders, it's not just the Department of Space, but other departments as well, and they pitch in with various elements that are required for the program. And we are looking at a sustainable and affordable human and robotic program to explore the solar system and beyond. So it's important that we realize this, that the first Gaganyaan mission, we might be looking at just the low Earth orbit, which is at 400 kilometers, but it sort of doesn't serve any purpose if we are not looking beyond that. It's not just the demonstration of flight. We have to look at maybe having a habitable platform in low Earth orbit, maybe also look beyond that, cislunar orbit and things like that. So the long-term objective or the vision is to extend human presence across the solar system, starting with human spaceflight to low Earth orbit. And in the initial phase, we are trying to demonstrate the capacity of carrying at least 1 to 2, 3 crew to first one orbital period, and then maybe go to at least 3 days, 4 days, and do microgravity experiments so that we develop those end-to-end capabilities. And even before going to the human mission, there has to be 2 unmanned developmental missions. This is the configuration of Gaganyaan mission. Of course, as I said, we will be using the launch vehicle Mark III, but this will be upgraded to make it a human-rated launch vehicle. I'll touch upon what it means to say human-rated launch vehicle. But in terms of the stages, we will have the initial booster stages of solid propellant rocket motors, which is HS200, the human-rated S200. So it carries around 200 tons of HTPB based composite solid propellant. Then there are the liquid stages L110. So each of them, there are 2 on either side. So each of them carry, the L110 stage is the core one. The S200s are the boosters on the 2 sides. So L110 stage carries around 110 tons of earth storable liquid propellant, which is where UDMH or unsymmetric dimethyl hydrazine is the propellant, and nitrogen tetroxide is the oxidizer. Then you have the cryogenic stage, which was earlier C25, but now we're going to use C32. That is 32 tons of cryogenic engine, wherein you will have liquid hydrogen as the fuel and liquid oxygen as the oxidizer. And then above that, you have the orbital module, and the details of the orbital module are given on the right side, where you have the crew module. Maybe you can see that there is this yellow crew which is lying in reclining position on the crew seat. So, so there can be 2 seats like this initially. So the crew is here, and then you have various systems to support the crew. You will have a console, of course you will have the crew seat, you will have the life supporting systems like the canisters, the avionics packages will be surrounded behind a liner. Then in the service module, you will have the solar panels, the radiator, you'll have the propulsion thrusters and things like that. We are looking at an orbit of 400 kilometers at an inclination of 51.5 degrees. And as I said, 2 to 3 crew, up to 3 days, and this is the vehicle. Now, an important thing is the crew escape system here, which is essential. So I'll come to the details of the crew escape system. Now this is the mission profile. Is it visible? Yeah. Okay, so this is the mission, sorry. So this is the mission profile. You can see how each stage performs, and then it drops down, and then you have the orbital module getting separated at 170 kilometers. So essentially it's an elliptical orbit initially, and then it circularizes to 400 kilometers, and then the crew module is there in the orbit, and then the re-entry part is shown in the other curve, which goes from top left to down right. So it enters the atmosphere. You have the parachutes getting deployed at something like 7 kilometers altitude, and it's a staged parachute deployment. So you have large main parachute. First there is the apex cover that is separated, and then the main parachutes get deployed, which is like 25 meters. So there are 3 parachutes of 25 meter in diameter. Then you have the drogue parachutes, and finally it splashes down at a safe velocity. So what we are looking at is something like 8 to 8.5 meters per second splashdown velocity, and at a distance which is easily recoverable for our maritime agencies. And you can see that on the right side, essentially we're looking at somewhere close to India. So if it's the 16th orbit, the recovery will be close to Andaman Nicobar, and if it's the 17th orbit, which will be after 24 hours, it will be close to Gujarat. So these are the 2, but then being a first mission, you will also consider all off-nominal situations and contingencies. So you will try and see what happens if it is in the 4th orbit, 5th orbit. So then you tie up with international space agencies, and normally, as per the international legal framework, the countries support in rescue of astronauts. So there are legal instruments. You will have to tie up with some industries, maritime agencies, if there is some payments are required. But normally that is the case. But even in those cases, you look at places where you can recover. So there are windows where you splash down at a place which is not very cold, which is not very turbulent, and things like that. Now in terms of the program execution strategy, and which is the central theme for today's talk, I think what changes for ISRO from a normal space mission to a human space mission is the kind of reliability that comes in. So why we keep referring to human rating as the most important thing is because the reliability of each system needs to improve a degree higher. There is very high priority on crew safety, and you achieve this by a step-by-step approach with, of course, the design, realization, but additionally on extensive qualification and functional tests, and then there are crew escape systems. So in terms of human rating, there are certain things which come in. You do the qualification test, functional test, and it's not just enough here to demonstrate on the ground, but you also try to create platforms where you could sort of reconstruct those situations in near flight conditions, and then you go over to the uncrewed missions and then to the crewed mission. So especially for the critical technologies like crew escape system, parachutes, life support systems, you've got to test and test again, and only then you achieve this human flight certification that is required. Now, just to bring out the essence of reliability and human rating, I think it starts from the philosophy itself. So now the focus is not on performance optimization as it had always been. We were always looking at maximizing the thrust, impulse, minimizing the masses, but here you can afford to forego much of that for crew safety, because that is of paramount importance here. So you enhance the safety margins. In the normal missions, perhaps you were working with something like 1.25, now you enhance it to 1.4. So you can lower down the operating pressures, you can work on slightly enhancing the thicknesses, the insulation can be slightly increased. Then you build in redundancies, perhaps in the normal missions, dual redundancy would be good enough. But herein, especially for electronics packages, for the launch vehicles, you go for quadruple redundancy. For some of the non-critical parts of the orbital module, you can go for triple module, but others, you go for quadruple redundancies. Then there has to be system of flight heritage. Everything has to be flight proven. So, now we have had 6 consecutive successful flights of the launch vehicle Mark III. So there is good pedigree. And good thing is, from ISRO's perspective, we've always tried to use many of the systems which were proven in the earlier flights, like PSLV, GSLV, and then to Mark III. So there is good pedigree available. We go for space grade avionics, and that means that it has to be radiation hardened, it has to be tested for all environmental levels, and you go for quadruple chains. There has to be an integrated vehicle and orbital module health. So it has to be an autonomous system to check the health of all the packages in a sequential manner. Then the testing of structures, thrusters, and separation systems, that has to be elaborate. And you look at the critical components like parachutes, crew escape system, and life support system more closely. Now recently in October last year, we had the first test vehicle mission. So the objective here was to demonstrate the working of the crew escape system and the parachute deployment. We had this on 21st October 23, and for this we developed another platform. We developed a new launch vehicle to carry it to 17 kilometers. So the idea is that we are trying to look at various stages in which failure can happen, and we're trying to look at those stages where it is more dynamic and where it is more risk prone. So those stages you try and perform these maneuvers. So in this we took it to that altitude, and then the crew escape system was separated with the help of the solid rocket motors of the crew escape system, and then the parachutes were deployed, and then it landed safely. And good thing was we could achieve what I was saying, that velocity of 8 meters per second, and also in terms of the distance from the shore. So it was sort of spotted by the Indian Navy, and it could be recovered. It was brought back to Chennai port, and later on the hardware is being refurbished for further use in some of these testings. Of course, for lower altitudes, you can also do this exercise. You need not worry about the crew escape system, but the parachutes you can test for different altitudes. So we also work with this Chinook helicopter-based platforms for testing the parachute system to up to like 4 kilometers. And this gap between 4 and 14, 17 and all, we can also look at some of the aircraft-based systems. There are also balloon-based systems. So we'll see how it goes in terms of testing the parachutes. So, in terms of the main focus being on crew safety, I think we work at 3 levels. As I said, at the, for the crew safety through mission design and system engineering, we work on high structural margins, enhanced redundancy measures. We try to keep the mission profile within physiological limits of a human being. In normal missions, you won't worry about this, but here you are more worried about what sort of G levels it is facing, what sort of vibration levels it is facing. So those become important so that it does not go beyond the human levels. And there has to be 100% visibility. So you use, in the other missions, you don't worry, only for critical stages like separations and all, it's important. But now you need to have continuous coverage. So you need to have 100% continuous communication with the crew on board. So we try and use data relay satellites for the purpose, or some constellations try and use for this. You have improved QA and QC protocols. Human factor engineering and ergonomics becomes important because they become central to the mission. Then there is enhanced safety through training. You train the crew extensively. In our case, some of you may be aware, we have 4 astronaut designates which have been selected from the Indian Air Force. All 4 of them are test pilots from Air Force. So they are very skilled pilots, and they have also got training on the Russian systems in GCTC. But here we're training them on on STEM subjects, on various operating procedures, on our launch vehicles, our spacecraft, and finally there will be training on the simulators and they have to handle the off-nominal situations. Then the survival training is important. The psychological and aeromedical training also goes on parallelly. They have to be in good shape, so physical fitness training is a constant part, so they have their physical fitness training sessions as well. And finally, through human rating, when we say, what it requires to meet the human habitation needs in space in terms of the life support systems and hygiene systems, no single point failure should result in loss of mission. So there has to be backup plan and crew intervention provisions wherever it is required, continuous crew health monitoring. The most important contingency measure is you should have end-to-end crew escape capability. So worst come worst, at every point in the mission, the crew should be able to abort the mission in good time and return back safely if things go wrong. Now, we've also tried to learn from other countries' experiences. We might be doing this for the first time, but countries like US have been doing it for over the years. So we've tried to see how they have dealt with this subject. So NASA has brought out this standards for crew safety. So NASA 3001, NASA Standard 3001, the volume 1 deals essentially with crew safety. And the good thing is they consider even the human physiological parameters as a system. So it becomes part of the design. So the entire engineering and design of a device, it involves the human being also. And this works in coordination so that, it allows you a nominal operation of a mission. You consider all the off-nominal situations and deal with them. And it allows you to have the successful completion of mission. And the volume 2 of this standard deals with the human factors, the habitability, and sort of the environment, the life support system, the environment inside the crew capsule. And you can see how much in detail they sort of bring out each parameter. Like I've just given 2 examples. For example, for temperature selectability within the crew module, they look at providing selectable set points in step sizes no greater than 0.5, so that it doesn't lead to a sudden increase in temperature. And the atmospheric control, so what are the controls required. Then there are human rating requirements brought out in NASA procedural requirements of 8705. What we have tried to do is we have also prepared our own requirement documents, like sort of what should be the allowable contaminant level, carbon dioxide, oxygen pressure, humidity, all those things. And they are still, they have to evolve in terms of standard, but we have got all the requirement documents with us. Now, this is a new system that we are building for the human space mission, which is called as the Environment Control and Life Support System. The objective of the system is to provide shirt sleeve environment while in space. So, it's important to understand this because this is something that has implications, wider implications for humanity, building a system like this. When we are devoid of resources, even on Earth, in places there are difficulties and challenges. Now, this is a system of systems. So there is one cabin pressure control system, then there is a thermal and humidity control system, there is an air revitalization system which flushes out carbon dioxide and brings back oxygen into the system. Then there is a controller and data acquisition system. You have ground servicing components at the launch base. You have sensors to monitor the levels of various gases. Then there are simulations, so that human metabolic simulator, and you do it for a larger duration. Then there are different human-centric products, and flight suit is sort of the crux of the system. So flight suit is like a backup. If there is a problem with the atmosphere inside the crew module and you see that you're not able to rectify this, just enter inside the flight suit and then give an abort command, because it can withstand for certain, let's say 2.5 to 3 hours, and within that time you can return back to Earth. So this is the ultimate thing. These are some of the human-centric products which different DRDO labs are building for us. So the emergency survival kit, it has food kit, hygiene kits, medical kits, the fire suppression system. Then you have how it is mounted. The flight suit is there. Crew seat is a very important thing, because you see, whatever loads come during the mission, one has to ensure that those are not transferred to the human body. And once again, when I was saying the reclining position in the earlier picture, we understand that the direction of G-forces is also important. The human body is capable of sort of withstanding more loads in perpendicular to perpendicular chest direction, that is GX direction. But when you look at shoulder to shoulder or along the spine, it can withstand much less. They are more vulnerable. So you try to orient the seat during all phases of the mission, especially the critical ones, such that your spine and shoulder to shoulder, you don't face those kind of loads. More importantly, you should also, the crew seat should have multiple layers. The first is a liner, which has to be configured according to the crew body. So actually it is molded, the shape is molded to support at every point of the body. So it is molded as per the crew. So like for each crew, we will have molded crew seats. Then it will have a pallet to mount the crew seats. Then it will have an attenuation system, which can be honeycomb or wire curling. So those kind of attenuation systems, so that when there is an impact, the attenuation system takes the impact and the human body is protected. Now, there are other aspects apart from this, when you look at human health in space and what are the challenges that we face. So today I think we don't have enough time to deal with all the things, but I'll just focus on few things which are there. Radiation is an important thing, exposure to radiation. So because beyond a certain level, the radiation can impact adversely, and this radiation can come from solar, from intergalactic and cosmic radiations and things like that. And there are only certain levels which a human body can withstand. So on an average, if you are, let's say, in low Earth orbit mission, you can have something like 0.4, 0.5 millisieverts kind of radiation. So a small duration mission is not such a big problem. When you look at 6 months duration, 1 year duration, then it starts a problem for the human body. Then isolation and confinement themselves can be can create a lot of issues to human psychology and health. Distance from Earth, higher gravity or lower gravity, and there are, you're closed all the time, it's a hostile environment. And these are some of the aspects in which, in fact, almost every part of human body gets impacted by microgravity. I've just tried to touch upon a few. So in terms of heart, I'll explain how this happens, but it can shrink, which can cause problems for astronauts after returning to Earth. The spinal cord can enhance, the astronauts become taller in space. So blood is pulled towards the head, giving astronauts puffy face. Bones, the density can lose, bone density can be lost. Muscles, they lose flexibility, they become more rigid, and that is why you see astronauts exercising in space. For long duration missions, even vision loss, in the sense that the same console which the astronauts were able to read during their ascent phase, they were not able to read after 6 months, 1 year during the return phase. Now, but the good thing is that these changes which happen to the human body are not permanent. So what we've learned from our discussions with the NASA teams and the ESA teams and all that is that once you come back and you have this rehabilitation phase, you are able to get back to your original health. And there is no data to show that the life of astronaut has been really significantly impacted. Like, one reason could be their healths are closely monitored, but there is no data to show that they live for lesser number of years. If Buzz Aldrin is still there and he's close to 90, so he's still alive. So it's not that these missions really impact for a long term. So that's a good part, but we need to understand more, and that is where data analytics can come into play. How to get all this data together and try to bring sort of better models to prediction how it will be impacted, and try to extrapolate to different populations. Now, just one example for the cardiovascular system. So what happens is, on Earth, gravity is always there. See, we have all born on Earth, we are all born on Earth. So our body has adapted to be on Earth. So there's always this gravitational pull to keep the blood to the lower part of the body too. But in space, the blood tries to redistribute in microgravity, and you have more towards the chest, and that's what causes this face congestion, and you see that astronaut's face becomes puffy. So at this point, the body detects a flood in and around the heart, so it tries to sort of reject this excess fluid that is coming in, and then the heart becomes slightly smaller. And when you return back, again there is this pull on the legs due to gravity, and so you have this orthostatic intolerance kind of problems. But you have mitigation for this. You train the astronauts, and you have these compression garments to deal with orthostatic intolerance. Decompression can be a huge problem. See, many a times we think that what happens, where people show like water droplets, what will happen if water droplets are there? So what we see is that water droplets are floating, but that is only inside the crew capsule where there is a life support system, where there is a pressure like on Earth. What happens if these water droplets are outside? It's total vacuum, so it will evaporate within no time. So if you have problems like decompression, it can be really fatal, because your saliva starts boiling, your tears start boiling at normal body temperature, the hypoxia and cold trapped gas expansion, all this can lead to death. So you have to have a good cabin environment monitoring system which can detect early any sort of deviation, and all these IVS spacesuits to take care of you. Now, based on all this information that we have, we try to sort of make figures out of this, make meaningful data out of this. And how do we do this? We try to see, okay, what are the injuries that are possible, at what loads these are possible. So what can cause disability? And you give some scales, what can cause fracture, immobility. Then what are the static loads, how it impacts muscles, strength and endurance, how it impacts your circadian rhythm, how much you sleep. So you train the crew accordingly. You start closer to the flight, you try to shift their circadian rhythm as per the mission. It happens even when you fly from one place to another on this globe. When you go to another country, 1 or 2 nights you can't sleep because the body is still adjusting. So it's much more severe there. And then human factor engineering. So one has to make a very efficient kind of consoles, layout, so that it becomes good for the crew for the entire duration of flight. Nutrition is important. It's not the same thing what you have here. The food that you prepare, how you package it, how you take, all that has to be different. And for us, this exercise is being again done by a DRDO lab. DFRL is doing this space food. Then the ergonomics is very important to compute the cognitive load, because it severely impacts the decision making. So depending on the mission duration, the criticalities could be different. It can be on different scales, but it needs to be provisioned, it needs to be treated. Now, so due to this, space medicine becomes a very important sort of area for us. And here, it becomes like a multidisciplinary challenge. You require engineering and medical expertise to work together. So it's no more an engineering domain when you come to human space flight. Here, engineering and medical teams, they need to work together. So the flight surgeons are part of mission management team. For us, the flight surgeons are from Institute of Aerospace Medicine from Air Force, and they've got the required training. They've got the experience of training pilots as well. And all these kits are to be designed, and there has to be biomedical instrumentation as well. Now, these are just some of the sample pictures on what crews generally train. So there are parabolic flights in aircrafts which can sort of reproduce microgravity conditions. Then there are human centrifuges to subject them to different G levels. There are simulators, hypoxia chambers, so they go with the crew seat and they experience and try to see what is the kind of endurance that the body has. Survival training is done for the crew. And this is where data analytics is very important. So when you talk about crew health, there is a lot of data available with American, European population, but data on Indian population requires to be collected. You can predict these health problems for short or long duration missions. Why I'm saying that sample population is important is because, see, COVID has taught us this important thing. COVID did not impact the entire globe uniformly. There were some countries which were more adversely impacted than the others. So it shows that human body, with respect to the region that we are in, with respect to the environment, the kind of vaccinations we have had from childhood, all these have impact on how we deal with these health issues. So they can be different for different people. Now we are doing one study, but there can be multiple such studies of cognitive load analysis with Indian Institute of Science, wherein based on eye tracker and EEG data, we are trying to map the cognitive load on the crew inside the crew module. But there can be many such studies. Ground-based analogs can be there, wherein specific analogs simulating spaceflight conditions can be created for larger populations. Some of the examples are the Hera and Chapia from the NASA. They have got this analog. So we need to have similar analogs. And these analogs can be for specific conditions, like let's say head tilt stand or microgravity. But they can also be for specific planets, like people try to have Martian analog and those kind of things, lunar analog. And in terms of reliability analysis, so huge number of tests and evaluations are carried out for structures, propulsion systems, avionics. So all this data could be used better through data analytics for computation of reliability. And just before closing the presentation, I would just like to say that it is truly a national mission. I've mentioned some of them during my talk, but there are others. So of course, IAM, crew selection in space medicine, Indian Air Force, the astronaut candidates are there, the supporters for the drop tests, crew recovery trials. Indian Navy takes the lead in sea survival training and crew training, and they're supported by IMD, NIOT, NIO and SCI. Indian Army also helps. There are CSIR labs like NAL, ADA is helpful on ergonomics, human factors and things like that. And there are academic institutions. Actually, I didn't touch upon the microgravity experiments, but there is huge interest across the country in microgravity experiments. In fact, both our announcement of opportunities got very good response, and we've shortlisted some 7 microgravity experiments for the uncrewed flights, and even for the ISS missions and all, there's a lot of interest. Then Indian industries, of course, most of this comes from the industries, and 9 labs from DRDO working on different human-centric products and parachutes. So with this, I would like to close. Thank you.
We'll have 1 or 2 questions. When this Gaganyaan is going to be launched actually, the date?
So probably we will have the first uncrewed mission this year, the unmanned mission. Probably in July, August time frame, we are looking at the first uncrewed mission. And depending on its performance, we will have one more uncrewed mission maybe early next year. So then we'll see for the manned mission, whether any changes are required, or immediately we can go for a manned mission. But we have good visibility of the first uncrewed mission because the crew module is ready, all the subsystems are ready, the launch vehicle is there. So I think we are anticipating the first launch to be there this year, July, August.
You are doing a great job. We are all eagerly waiting for when the human will land it. Thank you, Mr. Imtiaz.
Thank you.
Thank you for accepting our invitation, and thank you for David.
So now, thank you, sir. Thank you. It was very enriching indeed, because a lot of things that you spoke about systems and is very relevant to the kind of work we all do in different areas. When you talk about human and system and within the spacecraft and how all the safety measures are designed, it's all very relevant to everybody who works in the field of safety, sustainability, health, ergonomics. So thank you for the talk. Now we move on to the plenary keynote sessions. These will be held in 2 rooms, Gargi Auditorium and Maitri Auditorium. So the first, I would request Professor Krishna to announce the first plenary keynote for the Gargi Auditorium. Thank you, sir.
We'll have two plenary sessions, one here, other is by the side Maitreyi. Here we'll have 3 speakers, Mr. Rajiv Mangal, Mr. N.K. Lohia and Professor P.K. Ray. In the other Maitreyi, we have Professor Rautre, Dr. B.K. Verma and Professor Sudhir Misra. So we'll start, this is the Gargi. Here we'll have Mr. Rajiv Mangal, N.K. Lohia and Professor P.K. Ray. So I request some of you can go to Maitreyi also. So both will start simultaneously. Sunita, where are you? Bring it. Where is the folder, the chairperson folder?
ये clear up होगा ना? This needs to be cleared up now. Immediately clear up करो, table clear up करो. So this is your copy. Just give me 2 minutes.
And one more announcement here. So if you open your conference kit, you have a lot of things that you will need for the conference. So you have the session for plenary keynotes, online and offline. You have the full schedule of the conference, where it is happening, and all the links. So the conference is completely hybrid. We are hosting this on YouTube also, and you have the full details in the detailed schedule in your conference kit. You also have food coupons which you will be requiring for that. So maybe you could just go through the kit once. Okay.
Kindly bring one chair here.
Where is he?
I don't know. Professor Malti told he's on his
अच्छा, आप इंट्रोडक्शन शुरू कर दीजिए, will not be.
एक मिनट. ये आपका है? अच्छा. तो मैं क्या करूँ? आपका रख दूँ कहीं पे? दीजिए.
You don't worry, I will.
Wait. Good morning, everyone. I welcome you all to the offline plenary keynote session of SHADG 2024. I may not tell more about SHADG 2024 because you all would have heard a lot about what this conference is all about. So, Professor O.B. Krishnan and I, Professor O.B. Krishnan is the convener of this conference, and I, Professor Sunita Mishra, will be the coordinators for this session. We have 3 plenary keynote speakers here with us who have profound knowledge in the area of safety, health and analytics, and will enlighten with their gigantic experience they have acquired over the years. So to start with this session, I would like to invite our session chair onto the dais, Professor P.K. Datta, who is our Dean of Interdisciplinary Discipline and Biotechnology and Bioscience, IIT Kharagpur, and also a very senior faculty in the Department of Electrical Engineering. Please welcome him with a big round of applause. I welcome you, sir, and with this, I hand over the session to you.
Good morning, everybody. So, we have an interesting session here. However, we just, due to paucity of time, we will start it just with our first speaker, Sri Rajiv Mangal. Let me tell about something about Sri Rajiv Mangal. Rajiv Mangal is the Vice President, Safety, Health and Sustainability at Tata Steel. Rajiv ji holds a Bachelor of Engineering Honours degree in Metallurgy from University of Roorkee, now IIT Roorkee, and a postgraduate diploma in Business Management from XLRI Jamshedpur. He has done Advanced Management Program from CEDEP, inside France, Director Certification Program from the Institute of Directors, Thailand, and has attended Global Advanced Management Program from that country. Joining the company and graduate training in 1989, he has worked in various parts of value chain, including manufacturing, carrying, marketing, and sale of steel. He has held various leadership positions, including President and CEO of Tata Steel Thailand Public Company Limited. Let us welcome Sri Rajiv.
Good morning, and thank you for the generous introduction. I don't have a presentation, but I'll keep it free-flowing, and I'll give you an overview of what happens in Tata Steel on safety, health and sustainability, and aspects which are gaining more and more importance, and no longer it's about let's say efficiency, but these are existential issues. If an organization does not follow these, they may not last for long in future. We all know about Tata Group, and way back in 1895 the founder said that the purpose of the organization is not only to make profit but to support the community. So, in the Tata Group ethos, community and welfare is part of our working system. As safety and environment gained prominence, it got included in this maxim going ahead, and hence Tata Steel sustainability framework is linked on our vision. The vision of the Tata Steel company says we want to be the global benchmark in value creation and in corporate citizenship. So, we have 2 pillars of value creation and on corporate citizenship, and this is supported by the policies on health, safety, community and governance, which completes the aspect of planet, profit and the environment. So, the ESG aspect is linked to it. As a part of our deployment, we do a third party assessment on the materiality aspects every year, and it gets grounded on social environment and the governance aspects, and these get deployed in our long-term plans and on the annual business plans. At a group level, if some of you might have read or heard, Tata Group somewhere in 2019 or 20 took at an ambitious program which is called Project Alingana. Alingana in Sanskrit means to embrace. So this is a program taken at a group level to make sure that the group achieves environment sustainability. And Alingana talks on 3 verticals. The first is on the subject of emissions, something which is extremely critical. Tata Group and Tata Steel is committed to become net zero by 2045. For the complexity of the size of the group and for size and scale of Tata Steel, no other steel company in the world has this kind of an ambitious goal of net zero by 2045. The second aspect of Alingana talks about circularity, which says that how do we conserve water, how do we make sure we take care of solid waste, and how do we take care of renewables. So accordingly, there are targets taken on that. And third is about nature. How do we preserve nature, and that's the biodiversity aspect. So Alingana talks of emissions, circularity, and on the biodiversity aspect. Let me touch a bit on emissions. Steel industry accounts for almost 8% of the global steel emissions. So we are one of the largest emitters going ahead. And the problem is coal is used as a part of the production process. It's not only an energy source, it's part of the reduction process, and hence steel is called hard to abate sector. It's not an easy sector to reduce its carbon emissions. If I give a statistics, on an average steel companies emit more than 2 tons of carbon dioxide per ton of crude steel. So if Tata Steel is today making 20 million tons, our average emission size is 2.4, so we make around 49 million tons of emissions. West of the Western world, which is Europe and US, they are focusing more on transition. But India is growing. The steel consumption in India will grow. Today, the steel consumption in India is 1/3 of the global average. We consume around 80 kg per person. Global average is almost 250. China is at 500. So India's challenge and Indian steel companies' challenge is growth and transition. We have to find a way to grow our steel production and consumption, and we have to also find ways how do we decarbonize. And that requires capital planning, and that requires technology at a time when technology is not mature. So the decarbonization or the emissions part of the steel industry will depend on the producers like us, on the government in terms of policy support, and on the consumers who will pay premium. So all of us buy, if I can example, we buy organic food in the market, and you pay a premium for that. Okay? But how many of us pay a premium for green steel or a green cement? Currently nobody pays a premium for it. But if you have to make green steel or you have to make a green cement or any green material, today you need billions and trillions of dollars for that transition, because there is no easy technology available. And that's a dilemma for steel industry today. How to grow in a way that we don't land up with stranded assets, because steel assets you make will run for 30, 40, 50 years. And if by the time the taxes change in the country, the regulations change, you may be stuck up with assets which may not be viable. If I give an analogy, in Europe today, there is a carbon tax of nearly 90 euros per ton of carbon dioxide, 90 euros per ton. So if India emits on an average 2 to 2.5 tons, you will have to pay 200 euros per ton of tax. That's more than your profit. Okay. So to align the organization in that line, even though India does not have a carbon tax, Tata Steel follows an internal carbon tax policy of $40. So all our capital decisions we take, assuming there is a $40 of tax, what should be our decisions be taken on this side. So for that, we are working currently on improving our operational efficiency, which everybody does. We are also taking trials of subjects or technologies which will mature in times to come. Hydrogen is one solution touted for decarbonization for steel industry. Hydrogen can replace coal. But for steel industry, hydrogen to be viable, you need it at $1 per kg. Today there is nothing available less than $6 per kg. Okay. So what we are doing is 6 months ago, we injected hydrogen in our furnace, and that was the largest hydrogen injection in the entire world. The whole idea is we want to be technically ready with pilots so that once the commercially hydrogen is available, we can scale it up. Linked with this is also challenges of safety, because when you try out things which has never been done, when there are no commercial models, how do you handle the safety aspects? So our concerns during the trial was you have to transport hydrogen from somewhere, you have to store hydrogen bullets, you have to make pipelines which can transmit hydrogen, and then how will it behave inside the furnace? And these are all real-time furnaces. This is not in a lab. Okay. But it was planned well. We have a very structured, detailed process engineering technology team. We planned it well, did it step by step. So today, as a company, we are confident of using hydrogen in the furnace technically and safely. Now it's a matter of how we can scale it up, for which we are working with in-house production as well as looking at partners who will do it on build, operate and build, own and operate manner going ahead. Another thing which industry from an emission point says, one is to reduce, other is you can capture carbon. So this technically is called carbon capture. Okay. So Tata Steel also operates a pilot plant in Jamshedpur where we capture carbon. Technically, this carbon can be captured to make ethanol, methanol and many other products. Okay. But today the cost of this production is prohibitive. You cannot commercially make these products. So going ahead, our effort on emissions will be how we can improve operational efficiency, how we can increase renewables, which means greening of power mix, and be ready with these technical trials so that in due course of time they can be commercially deployed. In terms of circularity, steel can be rotated n number of times. Steel is 100% recyclable, okay, and that's the beauty of steel going ahead. But production of steel also generates a lot of byproducts. So if we make 20 million tons of steel, we also generate 15 million tons of byproducts, which is like slag and other things. And we have a division whose job is to generate value out of this waste. So last year this division had a turnover of 10,000 crores. So that's the size of the byproducts that get generated into the system. So our effort is nothing should be wasted. It can be put to use. For example, we give slag to cement industry. For making cement, either you can get clinker, which has a carbon emission level of around 680 kg per ton of clinker, or you can get slag which comes at zero. So a lot of cement industries in the country and around the world are working with steel companies, and that's a classical case of collaboration where our byproduct is a raw material for them and we reduce the overall emissions in the system. In terms of renewables, India has made a lot of stride. Today the proportion of solar is significantly going up, but the problem with solar and wind is it's available only certain period of time. You don't have 24/7, and you cannot run process industry with power on and off. So till we have an answer for power storage, and have a 100% reliable power availability, it will remain a challenge. But our ambition is to see that at least 20 to 30% of our power is actually green by 2030, and it can be used in the steel industry. The other aspect of sustainability is the environment. We heard in the morning about air quality index, and I was very happy to hear IIT Kharagpur operating at an AQI of maybe 20 or 40 numbers. Okay. We know the number in Delhi and Bombay. India has a certain standard for air quality index at different places. We can take a pride we comply to that, but gradually it is the society will decide what level of air quality you are allowed to operate with. Tata Steel has plant in Netherlands. There we operate with an air quality index of less than 5. Jamshedpur is 100, Delhi is around 400. Okay. Even at 5, the society is against us. They are saying this is too much. Okay. So the question is, gradually for process industries, it's not longer going to be legal license to operate, it is going to be social license to operate. Will the society accept you? Will the society welcome you as an industry from environment, from safety, from sustainability point of view, or they will say, we don't want you around us. Water is another big subject for any steel industry. We operate at very high temperatures, and east of India we know is water deficient. Okay. So the effort of the steel companies, how we can use and recycle more and more of water, going ahead and replenish back those waters. So Tata Steel and Tata Group has an ambition by 2030 we want to be water neutral. Whatever fresh water we draw, we put it back into the environment. As a big company, we have a very large ecosystem of suppliers. So Tata Steel also follows a responsible supply chain, where we work with our suppliers on the aspect of human rights, on the aspect of safety in their production systems, so that what comes from them into Tata Steel ecosystem is what it should form from a responsible supply chain perspective. Let me now touch upon an important subject which I gave in brief in the morning, which is on organization safety and health. Within the group and within Tata Steel, safety gets the highest priority because it is all about demonstration of care. It is not about I'm better than somebody else or not. Every life, every single injury is important, and that's why we have set an ambition of zero harm. How anybody who comes to our premise, anywhere we operate, goes back safe, unharmed back in the evening. Accordingly, our systems have been devised, whether it is on reward and recognition or on consequence, because a process industry has its own set of hazards. There are challenges of risk perception. I'm sure in the next 2 days you will hear it from the speakers. Different people have different risk perceptions. Now the question is, as an organization, do you allow different risk perceptions, or you want to have a uniform risk perception of people who work inside your plant? Because it's not a park, it's not your free space. You are expected to work in a certain manner, and that is one of the challenge we face when people take shortcuts. People don't put in whether it's a positive isolation or they have to follow certain rules, and in the process put their life at risk and put others' life at risk. So as a company, we are devising many interventions, including technological interventions. One of the challenge in process industries is youngsters don't want to come and work in blue collar job. They want to work in office. So can you run a steel plant from a distance? So today, a significant portion of our operations in Jamshedpur, we run few kilometers away from the steel plant. So you call it integrated remote operation centers. So with technologies and with sensors, you can transmit what is done in the control pulpit far away. If you can do it from 6 kilometers, you can also do it from 500 kilometers. So I won't be surprised 5 years, 10 years down the line, you may have a factory in Odisha, you could be running that factory sitting in Delhi or Bombay. So you have solving the challenge of safety at site, getting talent, and using technology to make sure that you get the best of the both worlds. Apart from physical safety, there is another thing which we learned from our colleagues in Netherlands, which is called social safety. How do you treat your colleagues? At the end of the day, it is the teams which find answers to the problems. And what they told me is that social safety means a safe environment where cooperation, equality, openness, and consideration for each other is important. It means work is a place where you feel at home, at ease, and you can be yourself. In a large organizations, in our system, we have got more than 150,000 people working at our sites any moment of time. Almost 2/3 of them are contract labor. Unless you practice a level of trust, openness, and a level of respect, safety cannot be achieved at site. Organization health is also become critical, more so picked up after COVID. We have recently appointed what we call as a chief wellness officer, so that you look at health and well-being in totality, not only on basic parameters like blood pressure, diabetes, cholesterol or the aspects which actually constitute what we call as a health index. So we are now looking at mental well-being, psychological well-being, and how within a team you can have an ecosystem which improves the overall well-being of the entire system. CSR is another key aspect of sustainability, because as I said, society will decide who will work where and how, and Tata Steel has been taking pioneer efforts. We have also realized from an emotional well-being, volunteering helps. So as you engage people into a larger purpose of life beyond what they're doing day to day, it also helps the organization, it helps the society, but it also helps the team from a well-being point of view. So we encourage volunteering. We have an app. You have different kind of supports or options available. You select which one of them, go out, and that gets recorded as a volunteering hours you are doing with or without your family in down the system. Any system cannot work if there is not an oversight. So as an organization, we have a board governance system which has CSR sustainability meeting committee. We have a safety, health and environment committee of the board, which looks at our policies, our performance, and challenges us to see how we can move towards our goal of zero harm, making sure that we are not environmentally adversely moving, as well as we move towards our goal of net zero by 2045. Within that, you have got systems which is on code of conduct, because what matters is how you are operating within the company. So Tata Steel has a documented Tata Code of Conduct, and we follow management of business ethics to take it forward. After doing all these things, it's a matter of reporting. So we have a well documented reporting system, whether it is on the integrated report, whether it is on the group reporting initiatives. Happy to share on the Dow Jones Sustainability Index. Recently, we are 5th globally among the steel companies, and we hope to aspire take it forward. There is a global non-profit organization called Responsible Steel. They look at the various aspects of company on operations, safety, health, and on the social side. And only 3 sites in India are certified to Responsible Steel, and those are the 3 sites of Tata Steel. And we want to see that all our sites in Tata Steel get certified to Responsible Steel in the next financial year. So this is how we believe we deploy, let's say, safety, health, and sustainability in the system. It's a very wide subject. I've given you a, let's say, a rapid fire update to get you a sense of the depth and breadth. Feel free to connect with us if you want to get any more details. My colleagues will be here for the next 2 days to talk of various aspects of safety in detail. Thank you very much for your patient hearing. Thank you.
Thank you. So now we are open to a few questions. Any discussion? Yeah, I think from the house, yeah, there is.
Yes, please.
What is that, in your opinion, we are lacking as in Indian organizations, we are lacking because these incidents are not stopping at any time soon?
Yes. No, thank you. Your observation is absolutely valid, and I'll give you a response based on my experience in Thailand. I was posted in Thailand for 9 years, so I've seen how does a culture in Southeast Asia operates, and we have operations in Europe, so I also interact with them. the basic difference which I see is the lack of discipline and following the SOP. Okay. The problem in our country is we debate too much. Sometime in the zeal of improvement, you question everything. Okay. But if you go on questioning everything, there is no time to implement it judiciously. So in Thailand, what I had seen, you have an SOP, you explain that SOP to them, they will ask you 5 times why this, why this, why this. Once they have understood why, they don't question why I am doing it. They then just follow blindly. This is the standard operating process to be followed, no shortcut. Okay. But when I see the systems in our factories or when I visit other units, we have every reasons to explain why I violated. Sometimes there is a production pressure, sometimes there is a time pressure, sometimes some system is not working. So discipline, operating discipline to me at site is extremely important. The way I was talking to my colleague when I was traveling, the way defense or armed forces operate, you have a sense of discipline. Okay. That is non-negotiable. Compliance to standard operating process at site is non-negotiable. If we are able to do it, I would say a significant proportion will be solved. Then there is a lot of role of leadership to make sure how those SOPs are made simpler, how the work at site is made hazard-free, where technology can come in to make sure, can I do things from a distance rather than touching everything at site? How this data is used for analytics to do prevention, okay, and not doing a postmortem. Many times we use technology for a postmortem, okay, but technology can be used for prevention. Today there are enough apps, enough systems available which on a screen can tell you these are 3 non-conformities. A message can come on your phone to say please move out of the hazardous zone. You can put the technology, but if it is not followed in spirit, you know, we have an issue. So discipline and commitment of the leadership team to enforce that discipline to me is number 1 issue. Okay. Followed by the knowledge and the learnings which we review, put back into the system to improve as a PDCA cycle. You know, every system can have a PDCA cycle, you can do it. And with technology, things can be much faster. Things can be free from personal interventions. Your view and my view cannot be different. There has to be one view. Okay. So I believe if we can follow some of these, at least the rate of improvement can be significantly higher than what it is today. Thank you. Thank you.
So I'm so sorry to interrupt in between. Since sir would be leaving, we would like to present him a memento in between the sessions. So now I request Professor O.B. Krishnan, who is not only the convener and coordinator, but he is also he is the advisor to the Center of Excellence, Safety Engineering and Analytics. He has 37 years of experience in Tata Steel in production, turnkey projects and corporate safety. He also has 3 years of experience in DuPont as International Occupational Safety and Process Safety Consultant. So, sir, may I request you to present a small token of memento to Shri Rajiv Mangal, sir, for his keynote lecture. Thank you so much, sir. Thank you so much for your speech. And now, may I hand over the session to Professor Datta, please?
So, thank you. So, our next speaker is Sri Nirmal Kumar Lohia. Sri Lohia was born on 14 June 1945 in Dinajpur, now in East Pakistan, now Bangladesh. Yeah, he completed his school and college education from Dinajpur and then joined the family business of industrial fabrication and jute trading. He relocated to Kolkata in 1968 along with his family. In 1998, he diversified the family business in the sector of industrial safety garments. Currently, he is the managing director of Tata Rodia Private Limited, MSME unit in the business of FR safety garments. ESPL has a production facility in Kolkata for domestic sales. The group's overall production capacity is over 100,000 garments in a month and employs more than 500 people. The business is now jointly managed by him and his son, Rohit Lohia, who has more than 20 years of business experience. As per their business expansion plans, the upcoming production unit of ESPL state-of-the-art facility in Kolkata, with the business growing 50 times over. An extremely quality person with an avid reader who can active interest in gardening. CE&T Lohia lives in Kolkata with his family. His presentation title is the Inauguration of Fire Research and Safety Garments in India. So let us welcome Sri Lohia to the stage.
Respected Chairperson, distinguished guests, ladies and gentlemen, I am honored to be invited in this august institution to speak on the evolution of flame retardant safety garments workwear in India. The evolution of flame retardant safety garments. Necessity is the mother of all invention. The famous proverb builds the care of resolution flame retardant priority today. Back. Global scenario and history. Protective clothing has been in existence since the time before Christ, when the kingdoms and dynasties like Greeks and Persians had forced war. It was the history. Then after, it was the industrial revolution that truly triggered the momentum of flame resistance protective clothing and made way to the dawn of modern protective wear. Since then, the world has seen a sea change of development in flame resistant protective clothing. It's short.
So you can ask them to next.
Okay. Next. Pre-1990s, no awareness about the concept of FR clothing. Workers in leading industries in the country were still wearing T-shirts, chappals, etc. Extremely vulnerable to fire hazards. No safety regulations mandating the use of FR clothing were in place. burn injuries because of exposure to various substances, including molten metal, flash fire, electric arc, and welding splatter were in commonplace. This is during 1990s. I visited several steel plants and saw this condition. Thereby, it came in my mind to introduce flame retardant, some kind of flame retardant garments in Indian industry. Therein, I came in contact with one company. They produce flame retardant garments in South India, fabric in South India. I tied up with them and started the initiative of developing flame retardant garments to Indian industry. Here is the data of Bokaro Steel Plant. You can see the injuries at that time. This is 1990 data. Maximum number of cases were seen due to electric flash, slag burn, flame burn, electrical contact, gaseous burn, scald, and chemical burn. This was the rate of injury during that time in 1990s. Thereafter, we started introducing flame retardant workwear in Indian industry. At that time, the Indian standard method for determination of flammability and flame-resistant textiles made for, these were the standards. No specific testing procedure as per industry norms. Common challenges faced initially. Reluctance among workers. When I started and visiting steel plants, I found these common challenges. There were reluctance on the part of workers to wear these garments because they were heavy, uncomfortable to wear for long hours, in spite of heavy accident rates. Lack of awareness and perceived costs. The cost was there, cost factor by the management side. These are the initial common challenges I faced during this period. In 1990 to 2000, early trials started. I brought some fabric from Proven brand from Madura Coats. I started trials, and my first visit was in Tata Steel. There I started a trial, and with 100 garments. But initially, there was heavy resistance from the workers' side and also from the safety professionals. They were saying, no, sahab, ye to chalega nahi. It is very difficult to sell. ये कौन पहनेगा garment? It is heavy, cost का factor है, nobody will wear this. These were the challenges I faced. And even I was discouraged that time. कि साहब ये छोड़ो काम, अब दूसरा धंधा देखो, ये नहीं बिकने वाला है. This is early period before you came in. So they in fact discouraged me, साहब छोड़ो अब दूसरा धंधा करो. But I didn't give up. I still continued because I thought there is scope and someday it will work. So Tata Steel started this, I started my journey from Tata Steel. I introduced some fabric, some garments later on, and as I said, I was told, साहब ये बिकेगा नहीं, आप क्यों इतना कोशिश कर रहे हैं? In fact, after third or fourth visit, I could sell some garments, and from there the journey started. After that, many other steel plants started to buy and introducing flame retardant garments in the, like Shell steel plants, Parik steel plant. They also purchased, and that journey started. It was a tough challenge, and we were selling 100, 200 odd garments at that time. After that, around 2010, different industries, including aluminum, copper, and gas, they also started using. Yeah, that was Alusep. Now we are selling not Alusep. The brand is different.
We have taken from you only.
You have taken from Alusep brand. This garment that were inherent flame retarding, that was suitable for aluminum industry and copper industry. So in Tata Steel and steel industry, you also selling this garment now. This was durable. Different aluminum industry, different industries, including aluminum, copper, oil, and they also adopted. Early adopters like the Indian steel industry led the implementing effort solution for in a broader way. Safety professionals in the industry began advocating the importance of compliance of PPEs. Here, safety professionals, they started to realize the importance of FR garments, and the compliance started from there. Worker adoption was still, but workers from worker side, there was resistance. They were not using. And also lack of mandatory regulation did not intensify the adoption for the management of the companies, because there were no incentive to introduce flame retardant. Some PUCs mandated the FR clothing. In 2010, ONGC started from us first. They started first time introducing flame retardant coveralls in their oil refineries. Newer products were developed, including inherent FR, lightweight fabrics, which provided better comfort along with protection. Nowadays, we have a lot of new fabric has come, lightweight, they're comfortable to wear and durable. From 2010 to 2020, more Indian companies were going global. Here more international companies came, and the international norms also came in. International exposure led to more awareness of global standards in the space. More and more companies started demanding better quality, adhering to more stringent international standards such as ASTM, EN, ANSI, etc. To increase compliance in workers, companies wanted more comfortable and lightweight products that would provide similar level of protection. That is why I will tell later that we have recently we come with more lightweight and durable garments with more designs. Present day, the government still, Indian government with CME, FICCI and ITTA are working together to introduce more and more flame retardant garments and of better qualities. FR products ended and become more lightweight. Now FR products has become more lightweight and more focus on aesthetics and adoption rate. Adoption rate is increasing adoption rate now increasing. The industry demanded more eco-friendly. Clear me.
Hello. Hello.
The industry demanded even their contractors to comply with FRPP regulation of the same standards. Now, in all the industries, even contractors are provided PPEs. Company management realized the value proposition of maximum compliance of FR workwear. Safety professionals across industries advocated and implemented stringent guidelines for usage of FR workwear. Now, across the industries, sir, in Tata Steel also and all the aluminum plants, they are using more and more. 100% compliance is there compared to 2000 when there is no uses. Nowadays, 100% compliance, and Tata Steel also in the aluminum industry, the other industry, 100% compliance. 2020 at present day, specialized garments are now being produced for different industries. For iron steel, you can see, for aluminum industries, we have iron flame retardant. For electrical, we have different, and for oil and gas. We are selling to all the different industries, now it is available. The standard now is IS 15748 textiles, equivalent to EN ISO, protective clothing for industrial workers exposed to heat, excluding firefighters and welders clothing. Protective clothing tested and certified as per the norm gives the wearer protection against brief contact with heat and flame. Various hazards that this standard covers include convective heat, radiant heat, splatters, molten metals, and their combination thereof. This is the current standard available. Current day challenges. Adoption of ever clothing in mid and small scale industries are still abysmally low, leading to avoidable accidents and fatalities. In small industries, there are challenges. The adoption rate is very low. Lack of awareness of benefits among safety professionals in these companies. Lack of awareness. Last mile implementation by government. Government is doing also implementing many things, but still there is a long way to go. The road ahead. Eco-friendly recycled fabrics are coming. Focus on garment design, stressing on ergonomics and aesthetics. The garment design has changed. Now more stylish garments have come, more stringent standards and norms. Better compliance leading to safer workplaces. Government regulation incentivizing the use of FR workwear in small and medium-sized enterprises. This is we are looking forward that more and more industries will come and 100% compliance in all industries across the board will happen. Thank you very much for your present hearing. Thank you.
Thank you, Sri Lohia. May I, is there, if there is some question, please, yeah. I think we are enthused by the presence of a senior person like Sri Lohia. Let us give him a big hand again. We will introduce our next speaker. Let him come.
You got the next speaker?
Yeah, we will pressurise. Just let him come. Our next speaker will be Professor P.K. Rai. He will be joining soon, I think. Yeah. So Professor Pradeep Kumar Rai is Fellow of Institute Engineers, currently Emeritus Professor, Department of Industrial and System Engineering and Advisor, Vinod Gupta School of Management, Indian Institute of Technology, Kharagpur. He has more than 42 years of diversified experience, 8 years in industry at GEC of India Limited, and more than 32 years of teaching and research experience at IIT Kharagpur, including as visiting faculty and investigator in a number of institutes and organizations abroad. With degrees of BE in Mechanical Engineering from IIES Tisipur, MTech in Industrial Engineering and Operation Research and PhD from IIT Kharagpur, Professor Rai has carried out a number of industrial consultancy and research projects, 31 of them, sponsored by organizations like Tata Steel, OFB, CAG, APO, UKRI, etc. Apart from his publication records of 4 books and 166 research papers, he has guided 20 PhD scholars and conducted various international conferences and programs, 68 of them, including many short-term courses and 4 NPTEL courses as well. A former head of Industrial System Engineering Department and Dean of Vigiswam of IIT Kharagpur, Professor Rai is a certified lead assessor of ISO 9001 registration.
Hello.
And actively involved in a number of industrial consulting and research projects. 31 projects he has completed so far. Let us welcome Professor Rai.
Check first. Check.
Hello.
Okay, it's okay. Interface design is perfect. Thank you, Professor Dasso, and good afternoon to all of you. I hope that I am audible. Okay. Now, without wasting much time, I will be just discussing this important issue. And in today's context, each and every company, whether micro, small, medium, large, whether it is manufacturing, non-manufacturing, whether service, whether agricultural systems, everywhere, I repeat, this ergonomic design or human factors engineering is a must. You know, before I discuss this issue, you know, you must be knowing what was the manufacturing system or for that industrial system, say 200 years back, 400 years back, 5,000 years back. So if you visit European countries and if you look at those, you know, the paintings depicting the conditions of the workforce in the industrial conditions. I had the opportunity to visit many countries, and the first thing I look at, that is, I must know what was the working condition of the workers or the operators at the industrial place. Is it okay? And there are hundreds of painters, the great painters, they have depicted their, you know, the living styles and all. Now, today, many companies who want to make their system a human one, H-U-M-A-N-E, It's a very tough job. It's not that easy. But even at the top management across the world, they have understood the importance of making a system human. Because if you go through the history, even today, you will find the hundreds of places across the world, the system is inhuman, and this system must be rejected. So what actually they do? The great people, is it okay? I'm a mechanical engineer. So when I was going through the mechanical engineering, okay, I used to know how to apply the principles of what? The principles of motion, energy, and the force in creating a system. That's the basics of mechanical engineering. Then we came to know that how to make a system for the human use, and then the problem comes. Now, this system was created for the humans, but the conditions of the humans, it starts with the slavery. Fortunately, in Indian condition, there is no slavery. But the kinds of systems we have brought in Indian system is a Western system. You know what is the reasons. Okay, so whenever something is coming to our country from the West, we just jump on that. Is it okay? So this has been going on, but today, whenever you say that I want to, design the interface, that means you're giving importance to the occupational health of a person. Don't call them as a worker. A managing director is also a worker, operator. So this way, and the kinds of work, the interface, and what we assume that if the interface is not proper, this is okay. But temporarily you can have financial performance. Hundreds of cases I can cite. But then again, in many cases, what will happen that the sustainability aspects, you will get a big zero. And even today, the BTech students, after graduating, they're becoming the startups. So I tell them that even when you in a company like the job shop, don't neglect this issue. Who will suffer? You will suffer. The society will silently reject your system. So this is the context, and obviously the company like Tata Steel, they have been adopting this one for a long time. I don't know about other companies. I don't have the data. I'm telling you, quite frankly, in fact. But whenever we take up, and other companies, like they're controlled by the defense organizations, is it okay? They have been using this human factors or say economics for a long time. That's why we find that the economics, our defense systems, has really given us a great contribution to the national cause. The people must be, working, must be happy, not in the sense that, okay, someone will give lectures on happiness or not that. That means occupational health. How do you define? Yesterday, what was it? Suppose, machine was absolutely, maybe, 200-year-old as a lathe machine, but only 50-year-old machines. Fine. And the person concerned was working with them. You are considered to be illiterate fellows. And you can play with them. That everybody knows in fact. And then because they used to come from the lower strata of the society, you can play with them. 100 things. It's like, hand-to-mouth systems. So bring them, very illiterate. So that was the origin. We must not forget that is the origin. Whereas, and they want to started living in an artificial environment. This manufacturing is an artificial environment. Whereas you will find that the kinds of systems we have in agricultural systems, the farmers, particularly in our country, what you find that it's more or less human. Because in front of you, the nature is there. So whatever the systems you follow, okay, must be matching with the environment. No other alternative. Otherwise, nature will take the revenge. That's it. You cannot fight with the nature. Right? So every industries now they have, aware about the importance of environmental management, or the environmental sustainability, as well as the social sustainability. The company might be saying that it's a great, okay, it's all the AGM meetings and all those whatnot. We all know, as an engineer we know. There are company's limitations. But the society is watching you. Suddenly you will find that the society has taken its hand from you and you are nowhere. So this has happened in the past. Right at this moment, many companies are dying also. Many companies are coming up, upcoming. At this point in time today, you can get the statistics today. Internet world. How many companies are dying? This is okay. So one of the basic reasons is, I must know what is the root cause. If I do not know, then who will know? If the managing director doesn't know, who will know? If the executive director doesn't know, is it okay? So today it's a good that Indian system permits this. Many other countries' system do not permit. Is it okay? So we are lucky, and that's why we will find that this interface design. Now the question is, I have used this term, mechanical systems engineering. How many of you are aware of mechanical systems engineering, not mechanical engineering per se? So whenever you try to make the system a human one, so that its longevity could be say 200 years, 250 years, there are many cases in fact. Okay, the company is running the factory. Company may run, but the factory must run. That's the challenge. A particular factory for say 70 years, 80 years. Is it okay? So what is mechanical systems engineering? Time is very short. Okay, I will try to cover. Okay, basic concepts of ergonomics, human factors engineering. I presume that you know in exact terms what is ergonomics, what is human factors engineering. Is it okay? And there is a society area in fact. And today ergonomics and human factors are combined in one society. Is it okay? So the definition is very clear. Research methodology. I will just quickly, I will highlight the application 1, application 2, ergonomics 3. Now what actually challenge you must have? Do you know what are the extreme conditions at your workplace? Face to face. When I was working in the industries, my main source of knowledge was the workers. That's it. I used to, make my hands dirty. It's not a white collar job. Like in a doctor's job, okay, can they avoid meeting with the patients? So you cannot avoid. Being an engineer, is it okay? If you can start working at the shop floor, you will find that the workers, actually many workers, they have got enough knowledge base, like in the Indian railway systems. We carried out studies on Indian railways. You will find that the absolutely primary data is to collect. No blah blah blah. Okay, so we used to go there absolutely 1 year or 2 years spending at the the year. And what you find that the persons who are working day in and day out is a huge source of knowledge. Respect them because they are the main players in the interface design. Is it okay? So today, our interface is poor. Interface design. This is fine. As soon as they start working, okay, you cannot hear anything or this doesn't work. Interface design. Today what has happened, that the system may be FMS.
Hello.
NC-based system, machine. Is it okay? Or, the person is also highly, literate. No, I feel it's not ergonomically designed. That's what the story is. That mic is okay. This is okay, huh? This is interface. No. Look, I'm asking. You feel uncomfortable. Your work is mind, getting this done. Okay. So this design is okay, fine. But for other purpose, not for the interaction purpose. Are you getting my point? If you call someone, instruct them, fine, this is all right. But can you think of giving a lecture to the students with this one? You are not a teacher. As simple as that. And obviously the students will not give you respect. As simple as that. Okay, so this design is all, it's not acceptable. Okay, interaction. This is all right, no? This is okay. But there is an interface over here. Okay. So root cause must be known. So that we do not get disturbed. So the system is designed for the human use. That's it. So here, first what we try to do, that means at your workplace some of the, extreme conditions where the people are, day in, day out, they're working. Obviously, that should be your process. Is it okay? That's a benchmark, in fact. That's a foundation. Like the mining, underground mining, are extreme cases. I hope that all of you have visited underground mines. Another condition is, the many hospitals and healthcare centers. We are doing one collaborative project with one university in USA. And our focus has been how to create an economic design for the product systems, human product interfaces for healthcare systems. Unfortunately, time is very short, I will concentrate on that. And here you will find hundreds of cases. This is okay. You are getting, the patient, but the person, the nursing personnel, including the doctors, they are becoming sick. The interface is so poor. There are hundreds of data in that. So can you think of, you become a sick, you go to the hospital, and the doctor or the other nursing personnel, they have become sick persons are treating a sick patient. Okay, what is the scenario? This is also one of the reasons that there will be human errors. There are hundreds of cases human errors are occurring in the healthcare sectors. So we created actually, but there are some dangerous operations. Is it okay? Dangerous operations in healthcare. Is it okay? The long-term side effects. You may be a cancer patient. Okay, that is one. There are many kinds of radiation hazards we have. Those all data are there. So what we propose that you have to identify the dangerous operations, and only for the dangerous operations you opt for automation. Is it okay? So the automated systems we have to. Then the dangerous operations, there are many cases. Like the Japanese organizations, what they have done. Actually, I made the Japanese organizations, they say, I remember in fact, in the year 1990, and there was a news that it will be 100% automated system. Okay, in a factory, 100% automated factory will come up in the year 2001. Today is 2024. They are not that cool that they will make everything automated. They say that it is required heavy material, sheet welding, everywhere they have adopted automation. This is okay, dangerous part. That means we are concerned about the economics. This is okay. So that is should be focused in other areas. Suppose you do, if it's like, there are many cases. So you pay heavily and the price is very high. Not the cost of purchase. Is the total cost. So many companies have adopted the total life cycle costing. So it's a direct. That means when you are saying today, yesterday what was it? A person joining a company, absolutely healthy. You know what is the meaning of health. And when he lives, he becomes an unhealthy person. So hundreds of cases of today you cannot do that. That means a person is joining and he is having, you also must tell others, what is your contribution? That means as a managing director, if you ask this question, is it okay? So I must be able to answer. To what extent, the design, environmental design, interface design is responsible. I have no right to make a person sick. Is it okay? So what is it? It's easier said than done. It's not that easy, in fact. And that too, not group-wise. I remember, in fact, when the Rishi Modi came over here, this is okay, several times in our department. And he asked one question. He said, is there any concept called, right to manage? Right to manage. He says no such concept as right to manage. Then why do you call this a management group and a labor group? Is it okay? No such system exists. So today, when you go for applying economic design, human factors-based design, and the mechanical system design, what is your main purpose? The main purpose is each and every individual counts. Don't say it's a labor group. Like, the Indian railways, my father was a railway official. 1970s, 80s, there's a category called gangman. My designation is gangman. Today, fortunately, that designation is gone. That means what? What is the mindset? Now, can you make a survey in the Indian sectors, our country? How many such companies are there? Everywhere you find the construction sites, everywhere. And these people are working over there. This is okay from the lowest level of the society. The lowest being poor. You cannot define lowest. It's from the economic perspective we are saying so. Okay, are you getting an advantage? It's a capitalistic system of production everywhere. Okay, so this is the system. So can you make it? So these are the the extreme cases. Okay, mining. So that case basically the healthcare case has all the data inside. Okay, there's a very good response. There are automatic technologies are available. Okay, so time is very short. Okay, so this is a mechanical system. So you know what is a mechanical system? What is mechanical systems engineering? A blend of mechanical engineering, computer aided engineering, okay, computer aided design followed by computer aided engineering, control engineering, system design engineering, and electronic engineering, all combined. This is okay. One of those days that I just become a mechanical engineer and I don't care for other engineers. And I become an electrical engineer, I say that okay, what Paul Novosti has mentioned, being engineer is a very tired mission. Is it okay? You cannot think one is this side, one is the other side. So whenever the economic system we try to implement, first what you have to do, that means you check on the economic system where do you stand. Is it okay? That's why we created one system which is copyrighted. We call it EPI. And it has come with the data, system has been validated with the Tata Steel many years back, in fact 15, 16 years back. And we validated the model and this has been copyrighted. Economic performance indicator, 15 factors. Is it okay? So I'll just refer to this. So mechanical systems define a number of perspectives, human factors. Okay. So what we try to do, economics actually, activities you carry out, below the neck, physical one. Whereas the human factors above the neck. Okay. But today, when you look at, the idea is, you find that the person is on the job. Okay. His body is there, whether his mind is there or not. Okay, that's the challenge. It's not that easy. Whether you can measure the job satisfaction. Job dissatisfaction, immediately you get indications. But if I am job satisfied, I will not tell you anything. This is taken as granted. Obviously. Is it okay? So you will find that out of 100 workers working under you, at least 10 to 15. Okay, in any problem comes, they call you. Is it okay? Given the interface design, we call them. Okay. So and they'll give you the solution. So this is okay. So purpose of HAT. So the disease of workers 1770. Okay, you must know. And Ray Matthew in 1748, he compared between human and machine capability those days. I'm telling you, in those days it was started with the slaves. Nobody bothers about this. Even in India, in our country, the railway officials, they used to play golf. Okay, during the war. I say everything will go there. Similarly, the tea industries, that's been the case. That is very short. Okay. So many companies they have adopted, like NASA. So only one place, if you go, once I visited NASA, and hundreds of applications. Okay, aerodynamic design, and this is the best, organization for the engineers. But you must know the aerodynamics part. Whatever you do, it is for the humans. Is it okay? Fine. So this is okay, based to human factors, USA and all. So this is human-machine interface. So today what will happen, the machine is very good, person is very nice, but when you put the person on the machine, you will not know what will be the individual reactions. And this present generation is facing this problem. And it's a very complex design. Is it okay? Even if you know ins and outs of the mechanical systems, it's not our orientation is inanimate object. For animate object, human body. Can you design it for the human body? Is it okay? So we know what is the sustainable interaction. So they say that if you make the system ergonomic, okay, it's all likelihood that your system will be sustainable. That's the challenge, and the first time in the history of mankind, this challenge gives a capitalistic system of production we are facing. It's open, it's right. Hey, I know, you are wrong. Even the child, they ask you, sir, can you, we have designed this particular set of toy, is it meant for us? How do you use? Is it okay? So there are hundreds of cases, and this I just skip. There's no point. This is the thing is very short, but everyone should go through all these details. Unless you have, the basics, clear. Okay, no amount of, the data collection will help you. You keep at the well. That's what we do. And these are the different machine interface. So HFE. Now, just to look at all this, what environment. Okay, how complex this one. Right, one after another. This is one. Interface design. Do you like it? Can you work in that environment? Can you work? Do you have empathy for them? Not sympathy, empathy. Then this is the condition, right? Okay, fine. These are the conditions you come across. And these are the challenging assignments. Is it okay? And engineers should take up, and then only the application of economics matters. Okay, so this is the interface. Okay, what are the interface? I must know. And what is industrial workplace? That is the limited one. Okay, now here, you come across everywhere. In your own factory, this comes. What was the reaction? This is an unsolvable problem. So if you say it's an unsolvable problem, you're avoiding the main issue. Hundreds such cases. So even at the job shop you have to do. This is challenging assignments. This is mortuary. Without mortuary, have you ever visited? Nobody should visit. But I have the fortune or misfortune of visiting mortuary. Is it okay? That's the bottom line. Okay, can you make the mortuary system like the human one? Without mortuary, can you run a society? No. So this is the situation in these are the cases common everywhere, construction sites. Even the child knows. Okay, so what is the solution? This sort of, the teachers, they don't know they are getting it. So the construction company, because we have collected data, but then the construction was, the system, okay, was controlled to election. So get the support, and there are many cases, in fact, this is Tata Steel, and all, okay. Krishna knows about it this time. Okay. So these are the cases. Interface. So many examples. So these are the few examples. Okay. So now we have this one. Research methodology FMSP. Okay. So this is three applications. All the details are here. One is for the construction site. The second one is here. The second one is the mining. Underground mining. Challenging assignments. So, and we think that's right. And the biomechanical modeling, physical modeling, you have to do, and then whatever the model you propose, you have to validate it. It's not that something you impose and a validation part nobody talks about. Whatever the AI and all those things, firstly you ask for whether it is a valid behavior or condition. You will find that many cases the humans are predicting it. So then the brain training attitude, model. So the training attitude is the first thing we have. Many such companies are used. In fact, I don't want to name them. Okay, they are all traders basically, nothing like. Okay, so I'm not talking about them. So this is all right. So all these things are here. Okay, so this last one. When you move to the last one.
Hello.
Of blood upon your house, if anyone falls from it, how many such cases are there? Last one, the Socrates. What are called the mechanical arts carry a social stigma and rightly dishonored in our cities, even in suffering from the world. For these arts damage the bodies of those who work at them or who have charge of them. Directly, the workers, the operators, who is working of the job, I have the respect for him, no one else. Is it okay? This is called karma yoga. First, I must identify who is working. Is it okay? Then his problems I am going to listen. Otherwise, I will not. And at them or who have charge of them by compelling the workers to a sedentary indoor life. Sedentary, you know, many of us, the sedentary lifestyle, being non-active, okay, and in some cases spending the whole day by the fire. This physical degeneration results in degeneration of the soul as well. Is it okay? Those days. Okay. So thank you so much. Time is very short, and you have understood that the subject is so complex. Is it okay? Many companies will do. Thank you.
So before I request Professor P.K. Datta to summarize the session and close it, I would again request Professor O.B. Krishnan to give a small token of memento to our distinguished speakers. So may I request Professor Krishnan to come to the dais. So now I would request Shri Nirmal Kumar Lohia Saab to come over the dais and receive a small token of memento from Professor O.B. Krishna. Thank you so much, sir. Thank you so much for your lecture. We all are enlightened with the knowledge that you have imparted in us. Thank you so much. Now I would request our esteemed Professor P.K. Rai sir to come over the dais and receive a small token of memento. Thank you, sir. Thank you so much. IIT has learnt a lot from you, and I hope this session, the participants would have also learnt a lot from your lecture. Thank you so much. So now, at last, I would request Professor Krishna to give a small token of memento to our session chair, Professor P.K. Datta, for managing the session so well. Thank you so much. Thank you, Professor Krishna. Thank you so much for giving away the memento to our dignitaries. Now I would request Professor P.K. Datta to close the session with his concluding remarks.
Yeah, thank you. First of all, thank you all the speakers, all the three speakers. That's a wonderful blend of the speakers from the industry and the academia. So such kind of blend will often work wonder for both of the persons from who are working in either industry or academia. So of course, sustainability is a very big word, okay? So, and also a very relative word. So that I may put a caution to all the discussion or fellow workers in this field. Sustainability is a very relative word. It's relative with respect to time, space and person. That's the final thing we should remember. It's a very relative word. It's a function of time, space and person. With that, therefore, everybody should open their eye and be cautious about themselves and the others. That is the one thing, okay? That brings the change. One should be conscious about himself and the others. With that, I thank you all again for attentively listening to the speeches of the speakers. Thank you all. Thank you.
Okay. Thank you everyone. Thank you so much for coming and joining this plenary session. Now we will resume again after half an hour. Now I would request all of you may proceed for lunch. We have the lunch in the foyer here. So you please enjoy the lunch and the conference. I hope you have a very good stay here in IIT Kharagpur. So we will start the first session, our first technical session in 7 different venues. One of the venue will be here and adjacent there will be another venue, and you can find all the details in the brochure given to you. So we will resume in half an hour at 1:45. Please enjoy. Have a good day.